Hello, hello. Let's get started. And as always, a tradition here. Let's start by running our motor. So turn on the power supply. And I actually think the example will run by itself, so we don't need to flash it. Let's see if it will spin. Please. Nice. Very nice. Okay, the plan for today is actually housekeeping. A lot of housekeeping. And this is a general advice. If you are developing a lot of firmware or software for yourself, you should always think in a way that if this software or firmware is usable, readable by other people. This is a very nice approach to go about, no matter your skill level, especially if you're a beginner. And from this point of view, you should always ask, I wrote a library, I wrote some code, like can a completely new person to my project understand it? And if not, what do I need to provide to this person for them to understand it? And I personally, I recommend this approach to many, but it's maybe not the only one or maybe not the greatest one. But the approach is to make big example libraries that are showing as separate features that are encapsulated in a separate example. So the example is very small. It shows very small setup, only things that are necessary for this example. And when you have a lot of them and they are all in a logical order, like any new person can just go read through the examples and understand what is happening. So this is why I have many examples in our main firmware. And this is what we will do today, because in last streams, we were implementing two main upgrades. We were implementing Watchdogs, which were not very complicated, but it is important to know how to use them. And we also were improving our advanced debug. And advanced debug is actually an incredibly important feature and not easy to understand at all. So today, to not accumulate any technical debt, to make a good work about it, we will do a chill stream of sorts. And we will focus on implementing examples the way I described. So I personally store them in a separate repository. And I think we will just go there and see what we have to work with to improve everything. So in my style, this was an old style and now it's broken because I renamed a lot of things. So nothing here will work, but this is fine because the examples we will be implementing are new examples. So in the new approach that I work with, every set of examples, for example, examples for Watchdogs, for example, for debug, will have a separate project. So that's exactly what we will do now. We will create a project. We will start with Watchdogs. They are much easier to debug. We will probably have only 8 examples total, I believe. And so this is very easy to show. So it will be a project. Hold on a second, did they change it again? Oh, I see. So it will be an empty project, of course. We are using, we need to specify what we are working on. And for this particular case, we will actually be working on a Nuclea board, not on our main driver, because examples should be runnable. And it's much easier for people, especially if you plan to bring a lot of people to a project, to run your examples if the hardware is widely available. So Nuclea boards are much better for this. And the boards I recommend when some people work with me on this project or similar project is G4 Nuclea. So we will use G474. I do believe it's RB. So we need to select location for our project, which should be inside this one, because we would like all our examples to be stored together, because whenever anyone has any questions, they would be able to just go to the examples and read them, or ask the AI tool to read them for them. But the main part here is that examples are stored together in a known location. So give me a moment to go and select the folder, correct one, off screen. Uno momento, uno momento. So it is here. Case development. Sure, and here we will have a new folder which will be named G4 Watchdog examples. Select, and this will be the name of the project as well. It will be C, and it will be executable, of course. So finish. STM32Cube IDE, starting from version 2, doesn't support CubeMX inside it. So if you are working with CubeMX, you need to install it separately and use it separately. So now, the empty project is not sufficient for us. We need much more than that. So yeah, let's use actually not this one. Let's use our clocking examples as a guide for us to organize this project. So we don't need this, and we don't need that, and we actually need to move this. This is just a system I have on how I organize all my projects, and this folder will be moved here. I believe it is not implemented here, but it should be implemented here. It isn't, but it is how it's supposed to be. So let's close the project. And what else? I actually need to add to do to my list to fix both of those examples, because I'm constantly changing, or rather improving, my style of project organization. So, and this is a recent change, and I need to fix it soon. So let me note it. Fix startup file location in clocking and Corsic examples. Noted for the future. So now let's keep going. We will need quite a few files here, and this is fine. So this will be the same. It's always the same. This is our includes, which will be like this. So let's start organizing the include process. This is not needed, but we definitely need this in our include path. We also need this in the development path, and we can remove this because all the folder will be thought to be source folder. So every single C file from this source folder will be added to the build, which is kind of annoying sometimes, but sometimes it works as intended. So let's make an example. Every example in this architecture is a separate folder and a separate build, so that you build them one by one, because you need to be spaced out to understand. Like, as I said, the idea here is that the example is the most isolated, smallest amount of code you need to make something work. So this is why every example will have a lot of code that is reused, but this code will not be stored in a function somewhere. Because this is just like every single example should be, you open this example and it doesn't matter if other examples exist, this example should be understandable. So this is the approach I use. So let's make our first example then. Example 01, and this is a big thing. Always, if you will try to implement this system or a similar system, always use more than one digit, because if it will happen that you will create more than 10 examples, you will suffer a lot if you want to for all of them to be well organized in your tree. So use 2 digits. And don't ask why I know and why I recommend it. I had to fix it twice, and it was a pain in the butt. So what will our first example show? It will be our independent watchdog, and it will show us watchdog reset. Watchdog no reset, actually. So this example will show us that watchdog will reset our system because we did not reset the watchdog. So okay, this file should have our main, of course. What? Oh, I see. So let's include it, of course, and also let's manage configurations. We will not have a release configuration in the examples, and this will be renamed to example 01 debug. And here specifically, hello Das, how are you doing? Specifically in this location, I don't use anything else, any text, because, for example, the use case for this is, for example, for me to tell a person, go and run the example 5 from clocking. It doesn't matter what the example name is, and a person will be much easier to orient by the number of the example. So that's why this is like this. We also need to make sure that our flags are correct, because we will use this example as a template for all other examples we will implement. So let's go. This is actually, today's stream will be a huge tutorial on how to use UID and how to organize your knowledge base with programming for embedded. So tune in for the learning. So toolchain is fine, whatever is installed. And now we need to go to our optimization levels. And here we need to use all-fast. And the reason for this is that actually debug doesn't care much. Like we don't really need debug. What we need is debug hooks. We would like to be able to see our variables in the live expressions when we are in debug, like this. But we don't want our code to be debug. We would like it to be all fast, and we would like to find errors as a fast. And for the code to be seen here, we don't need to use debug optimization. What we actually need for this to be the case, I didn't mean to close it. For this to be the case, in the debugging, it should be at the highest debugging level. And highest debugging level will provide hooks to all the variables to be connected to live expressions. But you can still run the all-fast optimization and you will be like golden. So that's why we use optimization as all-fast, but we use debugging level as like third, so that we can see all of it. And I believe it is all here for now. We will still need to do quite a lot of work in the paths, but that will come a bit later. So let's add our example path, because we of course need to include it. I'm doing quite fine. I actually spent quite a few hours before the stream cleaning up what we've done yesterday. Actually, I've spent quite a few hours after the stream cleaning up, and then today I woke up, I did my like home cleaning, like shopping, cooking, because today is like Saturday, the housekeeping day. And then I said I was cleaning up again, and now we're cleaning up the code. So Saturday is day of cleanup, cleanup all the way, in the code, at home, everywhere. So, okay, this is good. And here we also need to do this, apply and close for now. So now we should be able to add our C file. So sure, I should have copied the main function, but whatever, it doesn't important. It is not important that much. Should be void for embedded. It's not a big deal. Okay. And here, like this. So this is our base for everything. Sure. Now we need to, like all my examples are built at top of my SDK. And now we need to include our SDK so that we can set up clock, so that we can use debugs and stuff. So let's do it one at a time. So to do this, because actually it's quite interesting to explain how exactly I work with my dependencies, because I do a lot of small projects, and therefore I try to make as many things as I can as dependencies so that they are stored only in a single location. And there are quite a few ways to make the dependencies work as dependencies, and some of them are pain in the butt and some are not. And if people in chat are interested, I can explain how exactly I work with dependencies, because it's like a big deal. But for now, I will just continue including them. So my dependencies are here, and I link here directly. So what we need to include our SDK for G4. So we finish, it is added to the project. And now let's actually clean up the pass, because we would like the pass to be relative, not absolute, because I would like to push this to Git and for people to be able to clone it and to run it without any reset up. It should be runnable on any machine, on any device, like at any point. So for this, we go to our resources, link resources here, and we need to change this from the absolute pass to the relative pass. And for this particular case, I don't remember how many of those I will need, but I will need a few. Yes, I think this is correct. So now it is a relative pass, and if I will push it to Git and the person in any way in the world will clone it, and it will have, like the person will have the dependencies installed in the same root, it will work. So we've done this. Let's of course include it to our passes. The process seems to be complicated at first because the system is kind of complicated, but once you set up, it works everywhere and it works for everything. So it's actually a very nice system. And setup is not that complicated, it's just a lot of manual labor. And it cannot be automated that much because of how STMcube IDE handles the dependencies, and it's like special C project files. But like I find this process quite meditative, so to say. So I personally don't mind it at all. Okay, so we've added what we need here, and we also need to edit here. Like this. And now we have access to our SDK, which is quite big. These are all the files that can be used on any STM32G4. They are not changing depending on the device, so they are useful all the time. And we have our watchdogs here, so I don't think we will need to include much more, but we will see. I'm not sure now. We also need another file, one more. So what do we? Maybe we don't actually. If we are okay with running our system as without a PLL as a source clock. So let's actually not do it. Let's see if we will need it later, because for now, or rather, no, let's actually do it. Actually, I changed my mind. Let's do it. Let's copy it from here, because this is the cornerstone of all my project, this file, because it provides defines for all the peripheral setups and everything like this. And this is very important because most of the setups for peripherals in my system are automated at compile time. So they are known at compile time and then can be checked in compile time. So when we are compiled, we know that we are running with things that work. So let's add it here and let's include it. And this file will include a lot of things we will not need for now, so we will clean it up shortly. Like this. And for now, let's keep this. We don't need any of that. We need to keep this without that. And I think everything else can go. This can go, this can go, this can go. Yes, it is a bit of a mess for now, but it is an intended mess. It is as it intends to be by design. So very nice. And now what we can do, for example, here is call our pif. Hello? Should be int main. Did I make a mistake actually? Is main function as defined like this? Hold on a second. No, it's int main, sure. Okay. Oh, I know. I'm just a dumbass because of course I forgot to include it. So now we can start include our SDK files. So let's include clocking and let's include our watchdogs. So in here we can call our clocking, and I don't need to provide anything because the explanation on how the clocks will be set up are here. So, and I can explain why they're here. It's also kind of important. So we have our base frequency, which is always the same. but we need it as a constant so that we can use it in many other definitions. And we also have our CPU clock frequency, and we use here 150 megahertz. It's quite a lot, so let's move to like 64 megahertz. And that's all. I can change this number to 64 megahertz, and I can go here and compile this, and this will just work. I don't need to change anything else. So everything else is automated. And it's automated in a nice way. And like in case something is wrong, something is not functional on the microcontroller, it's actually will show an error. So now let's implement our first example. And our first example is example of our Watchdog resetting our system. So let's do pif. Oops. Oh, actually, I should put it much closer. I forgot about this. I'm so sorry. Independent Watchdog setup, not in a windowed mode. And let's say what's the duration we need. And also why we included our, yes, without this file, we would not be able to work with anything because this definition is system-wide and it's used in this function. So this function relies on this definition to select the timing, I imagine. Oh no, this function actually doesn't because it has independent clock. It has an independent clocking that is not related to our main system, but to use system delay, we will need to have this enabled. And this will come in another example, I would imagine. So how will we do this? We will set it up as 100. And this is 100 milliseconds. And if we not reset our system in 100 milliseconds, it will just reset. So let's also add something useful so that we can see if it worked correctly. And how will we do this? For example, on Nuclea boards, there is a GPIO. So let's add a function that will be only here is setup GPIO. Let's set up LED. It will be more than enough for this example. Sorry. Terribly sorry. Need a drink. So let's implement it. But for that, I actually need to remember what pins the LED is connected to and how do I learn this. Let's say Nucleo G474RE, and let's just Google it. I don't want a PDF, I want an ST website. Why is it PDF? No. Us. Schematic. Sure, product. Sure, and here on the ST side, sorry for the flashbang, we can go to, I think it's documentation rather than code resource, or actually code resources. Bill of materials, manufacturing files, board design project, board schematic. This is what I need. And this is the most recent one. I think they all should have the same information. And here we just need to find our user LED, which is actually user. Was. Is this all? It should have. Oh, it's just called LD2. Okay. But the main point here is this is connected to PA5, which we can see from here. It's opened by a transistor and is connected here. So we know that we need to set up PA5. And how do we do this? Is we enable clocking first. Actually, let me just copy and paste my own setup code. It will be much faster this way. So let's see. I'll go here and go and find a nice setup function. And go back to my example. Oh, of course. We forgot the most important parts actually. And the most important part is like how our project will know what MCU it works with. Because currently we have absolutely no files related to the MCU. So we need to add them. MCU course. And here we need to do, I actually can just copy this as well, like this. And it has our CMSIS files, and CMSIS are the files that describe the architecture from ARM and our STM files. But this file is incorrect, so let's swap it from another example that should have correct files. It does, so let's switch all of them just in case. And now we need to add them to the build, of course. Also, I'm quite curious why this file didn't give me any errors. It gave me only warnings, which is unfortunate, but all right. Okay, so let's make sure these files are included in our project. So let's add them. We need both folders to be in include path. And here. Looks good to me. So now when we go to our, let's close this main for now. Let's put this main as our first file for ease of going around. So I think it should work now though. And it doesn't work. Why exactly? I don't think this is, oh, it is needed. Oh, okay. So we are still missing a few pieces to make this work. We are missing general utils. And I think that the dependence of the SDK on general utils can be a problem, but for now it exists, and maybe I will need to change the architecture of my system to fit it better, but for now we will need to add another dependency, another global dependency. So dependency utils and generic finish. And here let's also fix the linked resources path to use this construct. Very nice. Apply, and let's add it to the build path. So in the build, not here, path. Oh, here. Sure. Workspace and our Watchdog examples and our generic utils. And also let's add it here. So let's see if it will work. So it builds, everything builds. But we still don't have, seems, no, something doesn't want to work yet. So let's close the project we don't need. This one, for example, and things we don't need from this project. And let's see. Oh, it does build. Okay. But this doesn't work. And this should work from here. Does this file exist? It does exist. So why are you not building this? Or rather, you are building this without an error, but why are you not showing me the syntax highlights? Let's actually try to do it directly and see if it changes. It changes. Okay. This is interesting, quite interesting. I'm not sure why this is happening, because this file and this file are definitely in our includes, right? Correct? They are. So it should work. But it's kinda unfortunate that it doesn't. Without an error actually as well. And now we have an error. What? Hold on a second. And this is a very interesting one. Lib nano C, but I don't use lib nano C. And now we don't have an error. What? Sure, let's close this as well. Now let's fix this. Quick fix is fine. This is for this project, which we don't care for now. Okay, so everything should be fine. Okay, let's keep it for now here, but I'm not sure why it's need it because we have this file. But okay, if it works, it works. But also this should be included because like both of them are included here. Hello. So we need this file as well for highlighting to work, but it just doesn't want to work. What's happening? Anyways, we fixed highlighting. Let's just proceed with our example. We saw that our GPIO is on pin A5. So we need to clean fifth pin, of course. Let's remove the example code we don't need. Here, remove like this. This will be digital out mode because GPIO is out. Here will be used the GPIO A, and this is not needed. And also rename this for consistency with our registers. And now we can actually make sure that this works. Let's actually build an example without a watchdog first so that we are sure that this setup works. So let's call it setup LED. Let's actually call it example setup LED. It will be a better naming convention for the example. And here it should be very straightforward. Let's just do our dummy. Okay, we need to include timing utils. Include. Nope. Hold on a second. Timing. Oh, okay. Timing utils are also in a separate folder. Okay. We need one more folder of generic includes, generic dependencies. So let's include it. Just one more. I promise, only one more. It will be in utils, but it will be ARM utils. And I can explain why it's so much, like why the code is split in so many folders, because it does make sense actually. If you like think about it from the architectural point of view, it makes a lot of sense. But like it may look very annoying when you try to do like small things like example implementation, and I can fully understand this. But there is reason, and I didn't do it because like I'm stupid or something. I promise. Well, I might as well be stupid, but I didn't do it for this reason. Okay, so we edit here. We also needed to include pass. Let's see here. Not here, but here. And these utilities. And also let's edit here. Okay. And now it should work. So let's do timing utils. They are there, correct? Yes. And with this file included, we can call our dummy delay. And let's say we call it for 500 milliseconds. And we just toggle our LED. And to toggle our LED, what we can do is we can do it in CMSIS directly. So we just go GPIO A, output data register, and do XOR of this register with a pin we would like to toggle. So it will be GPIO ODR OD5. And this will be our simplest Blinky code. So this is also a tutorial on how to do a simplest Blinky code in my file architecture. And now give me a moment. I need to go and fetch my Nuclea board so that we can test it. Actually, it was closer than expected. So let me unwind it. Let's connect it to the USB, of course. Let's remove the debugger from our motor. Motor will continue working. It's independent of what we are doing right now. So how do I prop it up? I need something nice to prop it against to show it, and it should be not metallic, because otherwise I am at risk of actually short-circuiting pins together. So this should be okay. Something like this. And user LED will be around, let me do a closer view. User LED will be here somewhere. Here Here's user ID. So let's flash the code, and for this we will also need to make a build. This is a last step before we can start actually writing our examples. So let's do it. Let's go to the builds, debug configuration, and let's actually, for this, remove this to not confuse ourselves. And actually, let's just press this, because this will propose us with our first build. So we select what build we would like to use, configuration, and we use our first build, the first bug build, of course. And it will be called correctly without any explanation, because it's much easier for users to use later when you just need to see the number, not the name of the example. And I think this is actually all of it. This is correct. We will need to change all of it for every single build. And now we are flashing, and it says to us that we have an error, but I think this error is annoying, and this is compiler related, and it will just work. I promise. I can just flash it. Yes, it just works. So now what we should see is that when I run it, our LED should start blinking, and that will prove that both my timing code is correct and our project is fully set up and ready to be turned into an example. So I run it, and it's crashed. What? Okay. Hold on a second. Why did it crash? Where are we? Okay, this was unfortunate. Something is off with this project. It should be working. I do believe so. Okay. Oh, hold on a second. I'm back. Sorry. Actually thinking about it now, maybe my change with debug builds was incorrect. Let's just, for the sake of our sanity, remove the optimization level to none and see if it works. It builds, so let's refresh it. This is kind of awkward. I'm not gonna lie. Okay, so it doesn't work. Why isn't it working actually? What is going on? Does it not recognize this main as a main function it's supposed to run? Because we don't seem to have an entry point. Did I make a mistake somewhere here? Like, am I stupid? What is happening? And why is it happening on stream? Why now? So, like, I may be stupid. But let me just, for the sake of whatever I'm doing here, for the sake of whatever I'm doing here, copy this. And it's called correctly, and it's like, nothing is different. Like, what the hell? What is going on? I'm confused. So let's actually also see, do we have an ELF? We do. Hungry hippo. Yeah. Hulking for sure. So it seems like we... Hold on a second, we don't... Oh, we do have main. You promised it wouldn't crash. Damn. I lied. Tricked you. Haha. Psych. Well, I lied. And now I also have no idea why it doesn't work. It should be so straightforward. Like, what can even go wrong? Like, there is nothing to break. But things just don't seem to be working. And I don't think that main should be in a very specific location. It must just exist. Oh, actually, maybe I know what's going on. Hold on a second. How to debug something like that on embedded if you cannot use things like breakpoints? You can use things like breakpoints. The point is that what is happening right now is that our firmware isn't even starting. Like, I can see from the view I have that we don't have a starting point. And I actually think I know why, because this... let's move it here for now. I think I was too quick to judge the move, because I think the startup file has to be set in a path somewhere. Yes, you can. Actually, breakpoints are incredibly useful. Let me show you. I think it should work now, and I will show you that it works first, I hope, and then I will show you the breakpoints. No, it still doesn't want to work. Okay, so it still doesn't want to work, and I think I've broken something I wasn't supposed to be breaking. Or actually, no, I think I just need to fix one more thing, which should be here. And we should add source location in workspace. That is this and that, and okay, and apply and close. And now, now it should work. Now. Okay, now it doesn't build. This is a good sign. No, it doesn't. It will build. It's just annoying compiler error. That's... But now, this time, like fifth time is a charm. For sure. No, it still doesn't work. What? Oh, what is happening? This is so annoying. Let me see. Hold on, but startup wasn't saved as it was supposed to, right? Project name, startup, is includes. Oh, but I was supposed to add it here. My bad. Sixth time is the charm. Promise. My god, it's annoying. Sixth time is definitely the charm. Right? Yes! It works! Oh my god. And now, nothing is happening. And now we can put a breakpoint, and we are stopped at this breakpoint. And we can definitely see that we are writing something into the BIOA. And it is broken because here I have 10 and not 5, and I'm a dumbass. Now, like, ninth time is the charm. Okay, I need to bloody fix it later. That's annoying. But now, now it will work. Now for sure. So let's remove the breakpoint, let's start it. And now it blinks. Holy cow, this was such a pain. This was such a pain. Look, okay, success. We successfully proved that both my timing setup is correct and that our LED setup is correct. This can be removed. This is not important for this particular implementation. And now we can add a breakpoint here by double clicking. And why are we not stopping? Oh, pass. Okay, because our USB crashed. Nice. Let's do it again, and I will show the breakpoint working correctly. Oh my god. Hello. Brother. Let me flash it again. Now we are flashing correctly. I need to change startup file. I don't remember where exactly, but we will. Oh yes, we are here. We are stopped here. So if I play run, it will go for one iteration and LED is on. If I play run again, it will be off. So the breakpoint is working. And if I remove the breakpoint, I can just untoggle it here and just run. It will just be blinking. So breakpoints are working and they are very useful for embedded. And there are not very, but quite a few useful debug tools for embedded that are important to know if anyone would like to learn the embedded. So if you have any questions, feel free to ask. I'll try to explain. Now that we struggled through this, actually, for my sanity, let me go and check where do I need to change the startup file settings, because I do believe it's somewhere in the build settings. And here, let's see, let's go through all of them. Nope, nope, and this, not here, and not here, and not here. Not this, and not that. And this can be, why is it set to this? Oh, because I changed for testing. Sure, we can go back. Not here, not here. It is a path to flash file, not what we need right now. Okay, I'm confused. I think it should have just worked, but it didn't. Happens to the best of us, I guess. Let's see if our optimization level isn't breaking things. Let's make sure of it before we proceed to our Watchdog example implementations. So yes, it works. Now, let's get our Watchdog back. We set it up with 100 milliseconds as our delay. And what we do this here. Here we, let's say, Watchdog I reset. So this example will not work. So there is a reset function, but it will be called after 500 milliseconds. And the MCU will be reset after 100 milliseconds. And what we will see is that our LED, even though it's supposed to be blinking, will be always on. And this will indicate that the behavior is correct. That like the function and the Watchdog are set up as expected, the timing are set up as expected, and the behavior is as expected. So let's flash it, and now we should see that our LED is always on. Compiler errors are annoying, but we keep going. So now, if I run it, our LED will be just... Oh, it will not be always on because we never set it on here. It will be always off. But for the demonstration purposes, let's actually turn it on to show that behavior is as expected, because otherwise it would be seem that we just set up LED incorrectly. I saw in your Word document about that you die inside if someone tells you that you use Python or JS for embedded. Someone was telling me yesterday about embedded Ruby. Embedded Ruby, holy cow! Sheesh! I can't even imagine how you can like run Ruby on embedded. Like, what is embedded? What do they even mean by embedded? Like, if this person was talking to me, I would literally die inside. There's RR. Let's just set it to slow, 1 cycle per second. Oh, that's quite a performance. Quite a performance indeed. Beat set 5. 5, not 15. So now the behavior will be as is described. The LED will be always on. And this will show that our Watchdog works, and it just resets the microcontroller all the time. So let's run it, and our LED is always on, and it's kind of blinking, and it's blinking because there is an MCU reset all the time. So this is correct. And now this is an example. As a person who doesn't know how to use Watchdogs, you will come here, open this, and it's easy to understand because there are so little things here. this function, like it's general function, you don't really need to understand how it works. So this function is here, and this function is what you try to understand, and like you can go and read if you want to, but if you want to understand how to use this, you just know. And the most important thing of making examples is actually making documentation for examples. So this is not a finished example. Example is only finished when you document it properly. And documentation, for example, sometimes is longer than the examples themselves. So let me actually show how I do it usually. So let me go to the example, to the other example, to the main, and as you can see, this is the example. This is all the example. Like you don't need anything else. It's called Pika Ruby. I think it's compiled to C. Just seems weird to use Ruby for that. Oh, I see. So this is a trick. So many languages can compile to C, but this is also like just awful way to do it, I imagine. Because if you have some issues on the level between your Ruby and your microcontroller, like in the C output, and you don't know C, like you will struggle for like months. Not months, but days. Like I would imagine this to be an incredible pain in the like all the places. If I'm going to do something like this, I'll go for Rust. But Rust is, are you saying you will go for Rust to C compilation or just pure Rust? This is actually an important question. So let's add an example. So this example, most basic example, basic watch, most basic Watchdog usage example with Watchdog resetting the MCU. Resetting. So here, what this example does is sets up system clock with CPU frequency of 64, based on the defined here, correct. This will be a bit different. It also sets up independent, actually basic independent Watchdog usage. Whichever works low. I would imagine they both work, and I would imagine they both work badly. Are you an experienced Rust programmer? Like if you are not an experienced Rust programmer and you would like to try embedded just to try Rust, don't. Like please don't. You will suffer. You will suffer so much. And if you are an experienced Rust programmer, then go for it. Sure, I would imagine that there are like quite a few, like the architecture, the infrastructure is there somewhat. Not fully. I don't think Rust is supported by any official big companies that provide compilers for the microcontrollers. But there are a lot of third-party implementations for Rust nowadays for microcontrollers of all sorts, especially for STM32, because STM32 are just the most widely used, widely available microcontrollers like there are in existence for now. So it sets up independent Watchdog with 100 milliseconds reset time. Tries to blink LED every LED every 500 milliseconds, but fails due to Watchdog reset. So a person can come here and just read this description and understand what is going on before reading the code. And now how to test. We connect to the USB, we run the example in the debug mode, we check error log for errors, because like some of the clocking setup can be producing errors, and like we know that it's 0, so we always do this in all our examples. Nope, I tried Rust a little bit before, but I think between Ruby and Rust, I'm not choosing Ruby for microcontrollers. Between Ruby and Rust, you should choose C. Choose C. C is nice. I promise, C is very nice. But like, for real, just if you try embedded, just use C. You will thank me for that later. I promise. Okay, so this is checked. Connect logic analyzer. No, we don't need it for this example. It can be quite confidently checked without a logic analyzer present. So, in this example, observe that LED on PA5 is always on, and maybe stutters a little due to resets and reset up. Is this not a word in English language? Let me Google. Maybe I actually misunderstood. No, it is a word, right? But why is it like this then? Sure. Like this, and this just proves that this example works. And this example is developed for the nuclear. All of it is set, so now with this documentation in place, our example can be considered as done. And now we can do a second example, and now that everything is working, everything is in place, other examples will go very fast, and they will be very useful. Like, trust me, when the new person comes to a team, comes to a project, comes to like whatever, just comes to me and asks me like, how do I learn this? And I go like, go read examples. Now, actually, let's check if those are still needed here and if it still work. So now it works for whatever reason. Like, what? Was? Okay, but this is how it's supposed to be. Okay. And now let's start just stamping all our examples one by one. So let's go. New folder. It will be in here. This will be example 0.2. And it will be still independent watchdog. Watchdog reset. Did I make any grammar issue errors? No, I did not. Did I? What? I put it into the wrong place. It should be here, and this we should close. Here. So we added a second example, and now let's just copy our main there. And the process from now on is as following. We go to our properties, we go to our configurations, we add new, we copy the configuration from our initial one that works guaranteed. We call it example 0.2 and debug because it is debug configuration after all. So all our properties from here are copied, all our properties from everywhere are copied, but we need to change one place. And this place is here because we would like to use a new folder. We will use example 1, but we would like to use example 2 for build 2. So we just change it here and here. So in 2 places. Everything else stays as before. So we go here. Here. No, I'm a dumbass. Don't be a dumbass like me because I'm just currently working with first build. So let's actually cancel myself. Shit. Okay, let's do it again. And I made a mistake and I'm very sorry. Okay. And now let's switch to this configuration. And now let's change everything because without it, we were messing up our first configuration. So let's remove this. Let's add our second folder. And let's add our second folder to the source locations. And we are all done. So now we can switch here to the second configuration. We can try to build it. It will still build because example is functional as we were copying this. These are not the actual errors. So now we go to this example. This is already example 2, and we need to make it work. And to make it work, we just do, for example, 500 here and 200 here. And with this change, we will now see the LED blinking all the time. So let's actually go to the back configurations and let's actually close this to not be confusing us. So let's go to the back configurations. Let's duplicate this one, rename it to debug 2. And we need to do 3 changes. So this first change, second change. Actually, we need to do 3 changes, and the first change is the renaming. So we apply, we debug, and we don't have ST-Link connected. Perfect. Let's reconnect it. And now this example will just work. and just work as extended, so the LED will be blinking fast. Because we reset Watchdog before Watchdog resets us. So let's turn on and let's flash it. Second example. Okay, let's flash it again because it still tells me about the compiler mismatch, which is annoying, but whatever. And let's run it. And now we see that LED is blinking, and this means that our reset is not happening. That this code executes exactly as expected. So this was an easy second example. Now we need to update our explanation and keep going. We have 6 more to do with Watchdogs, and I would imagine we have like 10 or something to do with our debug implementation we were working on yesterday. So let's just do chill example implementations and chill explanation of questions of viewers if you have any. So the explanation update. Maybe I can do it off stream if people are not interested in me writing comments. Usage example without Watchdog resetting the MCU. So correct, still correct. This should be changed to 500 and this should be changed to 200. And it's not failing anymore. And it blinks. So this is exactly what user will see when it runs the example. Blinks. Okay, this is correct. One moment, I have a phone call. Be right back. Sorry, took a while, but weather reports don't have any other phone calls for today, so we can just keep working. So let's get back to our examples. Let's get back. So, changing the comments. Okay, all are correct here. Is blinking rapidly. 400 milliseconds period. 400 milliseconds because we have 200 milliseconds between changes, and from it being on to it being on again will be 2 changes. So it's 200 multiplied by 2. Okay. And here we need to say that Watchdog is reset. Oops. Every 200 milliseconds. So it doesn't reset the system at all. And we don't have any other nodes, but maybe make sure that this function is called with a significant time margin for the Watchdog to not reset the MCU during normal operation. Looking good. So 2 more examples. 2 more examples to go. Let's do them. So now we need to do the same example but with window, and window provides us 2 things. First is actually thinking about it now. No, we do need 2 examples, right? But we will do the correct example first and then the error example second. So let me explain, let me show and then explain. So let's create a folder. This will be example 3. Example 3, it should be in correct location, which is here. And example 3 is still independent Watchdog, windowed reset. So we are in the windowed mode and we still reset correctly. Let's copy our main here. We did, and now let's create a build. Add a new example 0.2 debug. We copy 0.3, of course. We copy this. This time we don't forget to switch, of course. Now we remove this. We add. No, I named it incorrectly. Uh-oh. Don't be like me. Now we're talking. So now we can change it. And let's go to our third debug example, add this folder. Okay, and let's also add it here. Like that. Line close, and now we can switch and it should build. Let's see. These are compiler errors, which are not errors, and they annoy me to death. But, so it works. Now we are at our third example. And here we need to set up in the windowed mode. And in the windowed mode, we will use a different function. It will be setup Watchdog windowed. So we will still use 500 here as our main reset, but we will also use a low side, which will be 200 milliseconds. And what will happen? If we call the reset of the Watchdog before this time, so for example, we had a reset, and then the next reset is called at 150 milliseconds. This will still reset microcontroller. And the idea here is that we would like for reset to occur in a very specific time window. And if it occurs too early, it is also a mistake. So this is why we use Windows for Watchdogs. So we remove this then, And now, correct reset will happen, for example, if we have 250 here. So this is between those two numbers, and this will work fine, and we will still see the blinking of the LED. So let's create the build and rather the debug configuration, and let's make sure that I am not lying to you. So duplicate, rename, boom, bam, bam, apply, debug. Okay. Oh, I need to reset again. Okay, sure, whatever. Let's reset. It's kinda annoying, but I don't think I can do much about it. And let's flash our third example. Okay, please flash. And we should see our LED blinking as expected. So let's run it. Oh, it doesn't blink. What? So we have an error here. How curious. How curious. Okay. Let me see. Let me see. I don't think this is correct, actually. Let me remove this code. Let me take like that, because I do believe it's supposed to be like this. This is a wrong main. Let's open our main. Now let's flash again and let's see if it works. Let's see if this is the fix. Holy, please flash. Is this the fix? And let's run it. It was not the fix. How curious. Okay, so now this is an interesting issue to have. So we have a reset. Then let's flash again. Now that's with the old implementation. We have an error here. Even though I've tested it before. So do we have an actual error? We don't. So can you please flash? Hello? Hello? My God. Brother. Oh no. Oh no. I flashed the first example. That's why it didn't work. I was flashing the wrong example. So I have no idea if my changes work or not because I was flashing the wrong example. So actually, let's get this change back and let's make sure that we are flashing the correct example this time. 3. My God. Stop. And let's see if this is the fix. It is not the fix, so okay. So we have a bug here then. Okay. Nice to know, I guess. Alright. So let's say I'll keep this as a default. I will try to work with. Let's go here and see. No, what the hell? It wasn't supposed to be like this. It's supposed to be... Oh my God. Brother, what I've done. Should be like this. I from 2 days ago was a dumbass. So key, set prescaler, timer, and wait for this to finish. And we don't need to do this because this will set up. Actually, this is fine, but this is not fine. This is not fine. right? Wait a second, what? No, this is correct. But what am I doing? So this is the pass that is being run. And the pass that is being run is here. So this is actually correct. And this is actually correct because, okay, I'm just stupid. Don't mind me. Now, actually, how do we do this? How do we see what is wrong? How do we see what is wrong? Let's go to the main and let's say, for example, I put 450 here. Let's see if it will work. Oh my God, stop. Let's see. Let's run. And it works. Okay, so it works here, but will it work here? Will you? Let's run. It still works. Will it work here? Brother. Okay. Let's run it. And it doesn't work, so now it breaks. Very interesting. So let's actually switch the lines and do the same experiment. So flash first here. Oh my God, please stop. How do I fix this? Someone help. Where is my compiler setup? Fixed. Line close. I hope it fixes it. I'm not sure. So let's see. Let's see if it works. Let's see if it works. And let's run it. And it doesn't work. Okay, so let's go 350. And go again. No, it didn't fix my compiler. Oh my God. What do you want from me? Let's run again. And let's see if it will work with 350. It still resets. Okay, okay. This is quite curious. So with 450, it will also reset, I would imagine. And this mismatch is actually quite curious. Stop. I need to Google how do I fix this. Actually, let's just Google this after this test. So it doesn't work still. Okay, so this is then a correct way to do it, but there is a catch that it is not timing accurate. And why is it not timing accurate is an interesting question. So let's see how timing inaccurate is it. So let's go back to the main, wherever it is. Let's flash it again. No, let's Google. I'm pissed. No. I don't have an error. But next time I will be pissed. I will Google. Let's run it. And it works with 450, of course, but it doesn't work with 450, 250 rather. Let's go to 75. And let's see how inaccurate is it. And we also can add accurate timing estimation. So we might as well use it. So we have an error. So let's... Can I copy the text? Copy details. Description. So where is my chat GPT? Answer. Tell me. It looks scary. The linker is telling you the previous message usually about the code size and use section or symbol reference doesn't consider. Okay. Hey, what I just told you might not reflect the final binary because unused stuff will be stripped anyway. White appears. Using libc nana small standard library for embedded system, enabling. It is not a problem, but it's annoying as hell. So. Using libc nano A, which I don't. Enabling, probably some of these are enabled. Okay. What it matters. Okay. That usually means you need syscall C or... Oh, yes, I know. What? Wait a second. Hold on a second. I think I know. Because with version 2, they stopped shipping the files. Oh my god. Oh my god. Sure, let's go here. And let's copy both of them. Let's copy them here, and they should work fine. Right. I hope so. I hope it is a fix. I hope it is a fix. Close project. Let's close our ChatGPT. I already did, I guess. So this is fine. And let's try again. No errors so far. Maybe it was a fix after all. So let's run it, and it still resets. Very interesting. And so if we have 300 here, just for my curiosity, will it work? Okay, we don't have errors, so we fixed this. Annoyance is gone. And 300. It still resets. And it's 320, 310 actually. This shouldn't be happening. I would imagine that this shouldn't be happening. And run, and it works. Oh, very nice. Now let's actually measure the times correctly. Because we do profiling, setup, profiling, enable duty counter. And how will we measure the time? We need 2 timestamps. Timestamp 1. Actually, we need only 1, but let's 2 for easier understanding. And let's put here our new int 32 duration. And this duration will be in cycles. And we will need to convert it to milliseconds later. Should we do it? Let's do it. Float. No, this will be annoying actually. Let's not convert it. Let's convert it using calculator. So, how do we measure the actual duration of time that is happening here? We just do timestamp. Actually, no. Profiling. Save current cycle here. And we put it here as well. Let's say here, right after reset. And we just calculate our duration cycles as a difference between the two. 2 minus timestamp 1. So let's see what the value is in our debug view. That's right. Okay. Implicit declaration of the function, of course, because I need to include the file and I need to include it temporarily. So include profiling include profiling.beef. So let's run it now. These are all tools that you build up over time as you get more experienced and as you face more issues you have to solve. So this is quite a big value. So let's do calculations. This is the amount of cycles that are happening here. And we need to convert this to milliseconds. And to do this, we need to just divide this number by 64 billion. So let's open our calculator. Scientific, paste this number, divide this by 64. This is a very precise delay then. So this is exactly 310 milliseconds. So why are you not happy? Why are you not happy at all? Because otherwise you are resetting our system if we have less than that. Very interesting. Maybe we have an issue during the first call, but we don't supposed to have an issue during the first call, right? Let's do actually let me try. I have my suspicions about the while loop, so let's do it like that. I might as well be an idiot. Happens to the best of us, I guess. So let's see. It should be 210, and we will have a value here. We will just reset the watchdog, and it should work, I would imagine. So let's put it here. And let's also do this. And here, only one delay. And let's see if it works. I have my suspicion that maybe I don't reset something during initialization and the first call is a wrong call. So let's test it. Microcontroller is reset all the time. Now let's actually do 310 here, but 210 here. And if my suspicion is correct, this will work. And if my suspicion is incorrect, we will go and read the reference manual. We have 2 passes. So let's run it. It works. So yes, my suspicion is correct then. So I think that then it means that I am stupid. I am stupid. And I forget to do something in the setup. Okay, this is very nice. So STM32G4 reference manual. Let's real quickly check it up. 2000 pages, haha. Okay. So independent watchdog close read. When the window is enabled. So let's go and see our code. Let's switch to the better view. We go here. These are error checks. We will assume that we have no errors. So what do? Enable the watchdog, which we do by providing correct key, correct. Enable register access, which we do by providing correct key, correct. Write a prescaler, which we do providing the correct values. This is tested. Write this, also correct. Then wait until this, correct. What happens next is write this value, window register. This automatically refreshes the counter value in the log register. Writing the window value allows the counter value to be refreshed by PLR. But this doesn't work. If I do it like this, the first call is incorrect and it resets my system, even though it doesn't supposed to. Was? Okay, how good? That's interesting. That's a curious bug to have, of course. Very curious one. the first iteration works incorrectly. All other iterations work correctly. So how do we solve this? Okay. Writing the window value allows the counter value to be refreshed by the PLR when SR is set to 0. So writing this value allows the counter value to be refreshed by the RLR. So again, what is maybe this is an important note that I am missing, that I need to do something with RLR. And what do we do with RLR? Writing the window value allows the counter value to be refreshed by the RLR at this point. I think this should tell me an answer, but it tells me nothing. I think the answer is in the line, but I'm blind. I'm blind to truth. Let's start trying. First, let's reintroduce those two, and let's see if it helps. So, let's try. So, let's say we wait for this. Let's just wait for this. Maybe this is the issue. And then we will also introduce this one. And now, to test this, let's go back to the main function, and let's set this to 2 and 10. And let's flash it. Let's flash it and see. And run. And we're resetting, so this didn't help. Okay, so let's try to do this then. Just with this number. And let's see if this helps. By the PLR. I'm confused. Let's try again. But I'm so confused. Okay, let's run it. And it doesn't work still, so it didn't help. Brother. Send help. Someone send help. Okay, so maybe I'm stupid. I don't know. Writing the window value allows the counter value to be refreshed by the RLR when status register is set to 0. Maybe there is something as well. If the feature is enabled through device option bits, nope. This is also not important, and this is not important. This is all the text. There is nothing. When the independent Watchdog is started by writing this value in the counter starts counting down from the reset value of this. When it reaches the end of count, the reset signal is generated. Whenever the key value is written, is reload the counter and Watchdog reset is prevented. So maybe, just maybe, remove this, and maybe, just call me, maybe it's, I just met you, and this is crazy, but here's my number, so call me, maybe this will work. Definitely, maybe, yes, true. Very true. I'm a very confident embedded developer, as you can see. So let's run. It works! This was the fix! Fucking documentation. The documentation is wrong. Documentation is bloody wrong. It must say here that I have to reset this because this says that it counts from here. And if I set this to not this value, it's still counting from there and everything breaks. Fuck. True, very true. Okay, the most important part is that we solved this issue and now we are smarter than we were 2 minutes ago. So let's wrap it up. Let's test that it's resets at 19 dozens, 119 it should reset, and at 200 it should not reset. So let's test it, and if it works, then we are golden to actually finish the example. Da, 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 da. And run it, and it doesn't work now. Why? It should reset at this point, brother. Okay, so this is correct value, right? It is a correct value. Why? Tell me why. Tell me why. Let's again try. So it will reset, right? Pretty please. Run. It still doesn't reset. Will it reset if I set here to 190? No, no, no. Wait a second. Bloody hell. Fuck me. Oh my god. Now I think it just doesn't set up the windowed mode at all. Oof. 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 This is annoying as hell. Let me double check it. Of course. So, to modify them, first write the code in the key, write access to the register with a different value breaks the sequence. Okay, so protection is enabled, so our setup does nothing here. So at this point, this has no effect. What if we reset and then we open it again? What if we reset and then we open it again? Maybe this will work? Who knows at this point? Run. Okay, so this resets now. And this resets Y. What the hell am I? What is my main? Hello? Oh, I'm here. So let's put it like this. And let's put it like that. Let's see. Now it should work fine. Oh, I will be pissed. Fuck me. Sideways. Again. Oh. And it doesn't work now even. Okay. Are you going to work now? Brother. It still doesn't work. Hello? Oof. Oh my god. So let's remove both of them. I'm like quite literally guessing at this point. Okay. And run it, and it works, and it should work here. Okay, and it shouldn't work here. Even though it should, but it will not. Right? Yes. Oh, send help someone. I am dying inside. What can it be? So it's definitely about the first reset. So it's definitely about the default state of the registers. Actually, let's see the default state of the registers. So let's see it. So we are here. So let's go and just see it. Like, let's see it with our eyes. Where is it? It's here. So how are you supposed to work? How do you supposed to work? So started, the counter starts counting down from the reset value of this. When it reaches the end count, the reset signal is generated. Whenever the key value is written, the RLR value is reloaded into the counter, and the watchdog reset is prevented. Once running, it cannot be stopped. Hold on a second. No, actually. Let me open my calculator again. Let's see. And let's see. I wanted to check what is. But I know this. It will be 4,000 something. Right? F 4095. Okay. Very interesting and very unusable. The value is reloaded. Window option. The watchdog can also work in a window watchdog setting by an appropriate window in the reload operation is performed. While the counter is greater than the value stored in this value, a reset is provided. When the counter value is greater than the stored value. So there has to be a reset then. The default value, so if it is not updated, the window option is disabled. As soon as the window value is changed, a reload operation is performed to reset the down counter to... So it has to work. It should work, but it doesn't. Again, so we start from 500 and we count down. So let's think about it. Let's just think about it. Okay. So we start from 500 and we count down. What we expect here, it says, if the value of window is a reset is triggered when this value is smaller than this value, it resets. So the correct window for us to call a reset is when the counter value is smaller than this value. So this is a correct way to do it. And this value is set to 300 due to my implementation. So if it is 300, so there is a 200 milliseconds window in which we cannot call the reset. So I need to call the reset like at 200. It should work. Why is it not working? Ah! Oh, that's annoying. That's very annoying. Okay. STM32, G4, EVDG, window, first reset. How do I even describe the problem in a Google search? Timing mismatch. It's a terrible description. Mismatch. Yes, this is exactly the issue. Window option misconfiguration. Value is set. The watchdog must be refreshed. If a refresh happens while the counter is above the window, the MC resets immediately. What? Okay. Window mode doesn't work for you? Don't use it. Okay. Sure. Of course. All right. Sure. That's a nice solution. Ensure is called only after enough cycles have passed to ensure counter is below. But I'm not using whole, I'm using CMCs. Does window value cause MCU to reset if the window watchdog is refreshed often? Have window option, and if window is set, the value lower than this can cause reset. If the watchdog is refreshed too soon after previous refresh. Yeah, great, but it doesn't work the first time. I'm still searching to find an answer to this question since I already have a perfect watchdog. I mean the window watchdog. Why there is also simple watchdog, independent watchdog? This is not important. Can ChatGPT help me? I'm down, but I'm going to ChatGPT. Okay. On the STM32 independent watchdog window mode occurs. Okay. Occurs after first course. After the first. The first. Oh my god. Reset. Even though reset duration is correct. I checked this by making first reset longer and all other shorter. No, this is terrible explanation. Let's just see what it says here. Too many details. Okay, at first the reset likely still running and your firmware is refreshing too early, violating the window constraint. In the window mode, you must refresh the watchdog only after the counter drops below the window value. If you refresh too early, it triggers a reset immediately. Is correct, you still because you refreshed outside the allowed window too soon after the reset. Does not stop, keeps running through reset. The counter is reloaded automatically. The code restarts often. Refreshing immediately after init. Calling refresh before enough time was elapsed. But this doesn't answer my question. Delay before the first refresh. But what is the duration of the delay? Like, how would I know? How would I decide how long, how much should I? Like, I can add a delay. It's not a big problem. But how do I know how long it should be? Like, how would I know? I just love that. If window mode doesn't work for you, just don't use it. Okay. You know what? Let me ask my strongest friend. My strongest of all my friends. Which is Cloud Code. I didn't want to use him, but I have to. Okay, so let's open the project. Oh my god. This is annoying. So annoying. I just met you. So where the hell am I? I'm doing this off stream. 1 second, 1 second. Examples. Am I in the right mail? I am. So let me come to the examples folder and let me call the artillery, which is Cloud Code. And my question is, example 3 doesn't work with first delay being set to 210, but works if it is set to 310, even if the resets in the loop are set to be... I'm not showing what I'm typing because I don't want to leak my email. 1 moment. Because the loop resets are set to be... even if to be 210 milliseconds. So let's see what Claude says to us. Let's see if Claude can explain stuff to me. Because I'm annoyed. Okay, so go to hell. You are not answering my questions at all. Not answering my questions at all. And like, this is it. Like, it's 3 pages. 3 pages and a bug. What would I do about it? Like, what is this? Oh. Okay. Hold on a second. Okay, whatever. So any ideas? Will Claude find the issue? Will Claude explain us the problem? Any guesses in the chat? Okay, and while it is working, let's just keep going and working on our examples. Because they should work. So let's work on the first example right now. So let's just edit while we wait. New folder, example 04, IVDG, windowed, early reset, early MCU reset. Okay, so let's copy our main. It will be almost the same. Claude is still thinking about everything. And let's make our build configuration. It will be example 04 debug. Okay, and go here, remove this, add this, and remove that, add this, apply, close, and switch. Still thinking. Okay. Very interesting. So let's switch to the proper build configuration, which is this one. And in this configuration, actually, let's make example work anyways, and we will just fix this example when we know the answer, if we know the answer. And if we don't know the answer, we will need to document this bloody behavior, because this is unacceptable. Unacceptable. Okay, so example 4, main, move it to the left side. Let's see. So this example should say, it's not say, but should show us the early reset. So we remove all of this and we put, let's say, 150 here. And because of this, our microcontroller will just always reset. So let's add debug configuration, duplicate this, rename that. Okay, and here, and apply, and close. And let's build. Claude still thinking. We can remove those. We don't need them. We can remove this as well. And we can remove this from here. And this should just work as expected as a reset. So we are building. We have a debug folder. So let's run our configuration. Debug. Okay. And we need to reset the microcontroller, which is fine. So let's run it again. Oh my god. Let's run it again. Okay. And let's run it, and it should reset all the time, which works as expected. So we can document this example while we still have no idea about the watchdogs. While still thinking. So let's update the description. Example of independent watchdog resetting the MCU if watchdog reset is called too early. Okay, so correct. No, correct. It is correct. In the watchdog with reset time and 200 milliseconds reset window. And in my implementation, it meaning the time that has to elapse since the last reset for the new reset to not call the MCU reset. Okay, and brings every 150 milliseconds, but it doesn't blink. It tries to blink, but due to the reset being called too early, MCU will reset. Okay, so how to test? Check this, the same. Observe that. Let's actually copy the description from our first example, which is here. And let's go back. Let's see. Let's see. Observe that LED on is always on and maybe do the reset and the reset up. Yes, correct. Is called between the watchdog setting and watchdog window values. Okay, this example is ready. Code still thinks. It still thinks it's like 7 minutes. Okay, very interesting bug. Thank you, ST, for a very nice bug. So, and before, oh, okay, it split something out. Found it. The root cause is the object window implementation with this sets 3 and forbidden zone is the first 206 after reload. No, this is not a solution. No, why did you change the code, browser? No, this is not a solution. Fuck. Bloody hell. Okay, so let's finish reading and then we need to correct the code because this is not a solution. The problem is LCI clock tolerance. The STM32 LCI is rated plus. No, but this will work. Like I explained the situation, it works with 210 layers. So the assumption is incorrect. This assumption is incorrect from my statement, from the way I stated the problem. And why is this happening? Like, why so many answers? Because I clarified that it works when I put 310 and others are still 210. So this assumption is wrong. Okay. Okay. With RLR. Oof. As I explained, if I set the first reset time to 310 and all other are set to 110, it works. So the problem is only with the first reset. Please remove your changes and think of another cause. Okay, so what were we doing actually? What were we doing? We were working on the next examples, right? Example 3 is ready. Example 4 is messed by Claude. Let's make example 5. So, new folder. And the folder will be example 5. example 05. And this example will be windowed watchdog. No window, no window. And how will we call it? No window, no reset. So let's copy the code. Yeah. And let's start thinking. Let's start making our build. Configuration, a new example 0.6, oh 0.5 rather, debug. Okay. Let's switch to it and let's remove this, add this, and remove that, add this. Okay, apply and close, switch the build. Here, let's open the main. Let's open the main. Here. Okay, so, let's build it. Let's build it. It builds, and now we need to set up, instead of iWatchdog, we need to set up vWatchdog. And vWatchdog always has a window, but we can remove this window by setting our value to the same value. And this will mean that we have no window. Same values mean that we have no window active. Okay. We remove this and reset has to be with that. And I'm not sure that this will be even allowed because I would imagine, but I know that window watchdog has less of a time window and it's dependent on the frequency, but we use 64 megahertz, so maybe 500 milliseconds will be allowed. We will see in error log if we are mistaken. So let's try to flash it and let's see, and it should work. So it will be resettable, so it will be blinking LED. We just need to see if we have error here. So let's do it. Let's make a configuration, duplicate, rename in 3 places. First, second, nope, second, third. Apply and debug. No, a string connected. Bleh. Let's reconnect and let's flash again. Like this. Oh my god. Let's flash again, like this. So Claude thinks that the issues is in my code, not in the watchdog. Okay, sure. Sure, Claude, do your best, do your best. Okay, so let's run it and it should be was. Okay, let's see an error log. Do we have errors? We don't. But it doesn't work. Why doesn't it work? Hold on a second. Should it be 0 then? Wait a minute. It may need to be 0. Because I changed, yes, it needs to be 0. So 0 window means that we have no window. Okay. And let's make sure that it is correct by setting it to like 50. And we should see very rapid blinking. And run. Yep, blinking is very rapid, so reset is correct. Let's try 450. hope everyone is enjoying the stream who watches. I'm sorry for the issues we are having here, but this is part of the process. So, okay, and now we just need to not reset this. So how will we demonstrate that this works? Let's say we are enabling the LED, and let's say we try to reset it, but after 1 second. And given that it is out of the window, it will not reset. So this example will function exactly as first example, just with different watchdog. Okay, so let's run it. Let's try it. So it should be always on LED now if we set up everything correctly. Yep, so it works. Very nice, very nice. Let's document it. Example of windowed. Actually, what is the correct datasheet name? Because windowed, I'm not sure if it is the correct term. So let's see. Let's open this. It's window, not windowed. Okay, window watchdog. Example. Okay, then I need to rename the folder as well. Oh, no, I don't, because I used VVD. Actually, VVDG. I know how to not confuse myself with window or windowed, just use VVDG instead. Example of VVDG with no window. Setup, resetting the MCU. If set watchdog reset is not called in time. So it's set up system clock, same. No, it says sets VVG with 500 reset time and no window. Should I explain this? I guess I should. So any reset from 0 to 100 milliseconds is a correct watchdog reset. Okay. Tries to blink LED every 1000 milliseconds, which is 1 second, of course. But due to reset being equal to due to reset, but due to MCU reset. No, let me actually see how I explained it in the first example. I don't want to use different wording. Tries to blink, but fails due to watchdog reset. Fails. Is it informative enough? Is it okay? Let's use the same wording, but I'm not sure that I'm a fan of this wording. But fails due to VVG reset. Okay, connect. Check this. Observe is always on, and maybe, yep. Here. VVDG is clocked by HB bus, so the higher the bus frequency is, higher the lower the max window is. At 150 megahertz, it is barely 200 milliseconds, so be aware when using VVDG in projects. Okay, so this is a good example then. Let's keep going. Claude still thinks and still eats my tokens for nothing. A bloody independent watchdog. So is this looking good? It is. So let's make example 6. We have 3 more to go. and we can switch to debug examples, and then we will switch to improving the debug even more. We did quite a lot of work yesterday, and I also did quite a lot of work off stream. So there is quite a few things to discuss there. So let's try to finish this quickly. 3 more examples. So example 6. This will be VVG. No window. Reset. Let's copy it here. And let's create a build. Example 06 debug. Okay. Let's switch to it, of course. Let's remove this at this. Remove this at that. Apply and close. Switch. Build. And now create this debug configuration. Rename it 3 places, of course. 1, 2, 3. Apply. Debug. It's fine. It is fine. Switch to debug mode. We cannot. Sure. Let me restart the debugger. This little bugger. Okay, we go to main. And what do we see here? I'm sorry if the stream is boring for some people. The fun stuff will be happening next Tuesday. So anyone who is interested should definitely come to the stream Tuesday, because I think it will be very, very interactive is the right word to call it. But I will not explain what interactive means. So come to the stream and see for yourself. Come to the stream on Tuesday. But today we are doing housekeeping. Okay, Claude wants something from me. I don't care. And here we need to reset in correct time frame, which is this. And now it should just work. So let's flash it. And let's connect the debugger back, of course. And flash it and see it. Holy cow. He's still going for 13 minutes. Let's run it, and it works correctly. So example works. Let's write the explainer. Example of the VDG with no window. And also, guys, if you're enjoying the stream, please follow. I would appreciate it a lot. With no window setup, resetting the view. Setup that is reset in that is properly reset by firmware, so not cause the MCU reset. Very nice, very nice. So this is the same, sets VDG with 500 reset time and no window. Yep. Here it will be blinks. 250 milliseconds period. A bit too many zeros. Oh my god, Claude goes some like crazy places. He just tries to check all my SDK for errors, which is unknown. I hope. So it is set. And it resets the VDG so that VDG doesn't reset the MCU. Okay, good explainer. The same, observe that RG is blinking with 500 milliseconds period. That means that system is not reset by the VDG, or else you would have seen LED PA5 always on. Okay. Remove this, remove that. This is still a useful note, and this is a finished example. Let's go next. Thank you, next. So example 7. Yes, and I do this for every peripheral I work with most of the time. I just had a new code organization style, so that's why this project has lots of examples, but nothing worked because I'm changing the example organization methodology. And I just didn't find the time with me starting streaming 3 weeks ago to just go and change everything. But those examples are new, so we make them with new system in mind right away. Okay, so let's make 7th example, new folder, example 07, and this will be VDG, window, null reset. Right? No, it will be early. How did I call my example that doesn't work? Just call it just reset. Let's call it early. No, just reset. Yes. Okay. So let's see. Let's copy our main. Let's create a build. Not here, but here. Here, new example 07 debug. Okay, let's switch, remove this, add that. Go here, remove add this. Okay, apply, close. Now, close still works. My pure money. So, we need to set up window. So let's say it's 150. And we need to reset correctly. So it should be reset at 460 and it should work, right? Right? So let's see. It should just work. So let's switch. No, I changed the wrong main. I need to switch the build. Go to this main and switch it in this main and this. Need this. Okay, now we fixed everything and we need to add it here. Add our window here. 250. Let's flash it. So let's flash it, but for this we need the debug configuration, of course. Duplicate, rename 3 places. Boom. Bam. Brow. Okay, build. And let's see. Debug 7th. No string. Oh my god. Let's remove a string. And let's put it back now. And let's flash. Okay. Let's run it. And it should reset correctly, which it does. So it works correctly. And at this point, it should work incorrectly. So it should be LED always on. And this will mean that this Watchdog works when independent Watchdog doesn't work for whatever reason. So let's see, it should be always on. It is. So perfect. Last two examples will be very easy. We are almost done and we can switch to the debug examples, which will be much more entertaining. So, I lied, they will not be. Okay, so let's go here. This should be set to 60. And example of VDG setup that is properly reset by firmware to not cause MCU reset. Okay, let's say, with window. Window. Example of the setup of VDG with window. That it's much better. Not because MC reset. Okay. Sure, these are the same. This is not. It is actually. And 250 milliseconds window. So any reset from 0. Claude decided to change my code again for whatever reason. Holy cow. Was. I found the real cause. Let me look at the more thing to confirm. The LSI slot takes time to reach its nominal frequency after power on. Waits only for register synchronization, not for LSI to reach the real frequency. So when VNR is written and the first period starts, the IVDG may be ticking slower than 1 kHz because LCI is still warming up to 32 kHz. And the forbidden zone is 200 IVDG ticks. If those 200 ticks take longer than 210 milliseconds in real time, because LCI is at this frequency, the first Watchdog reset still has counterpath. This has stabilized. Okay. So past the forbidden zone. Interesting. Did you make this up or is it actually true? And why do you change the code without me like agreeing? Brother, why so much? Holy cow. Values synchronized into the LCI clock domain. A few LCI edges. It does not wait for the LCI to reach its nominal frequency. Still warms up and slightly slower than nominal. Real time lapses. Okay. No, but this will mean that you are still wrong because at 300 it still doesn't work. It still doesn't work at 250. Oh my god. You're wrong again. You are wrong again. So at 210 from VNR, right, the counter has only accumulated 180 ticks. Still above forbidden zone. It warmed up enough. The loop works because stabilized. Brother, holy cow. Please revert your changes again and don't apply anything unless I allow. Your explanation doesn't make sense because it still doesn't work even if I use things like 250 instead of 210 during the first reset. And also to potentially confirm your theory, can we enable LCR separately? Question mark. Okay, anyways, let's keep going. Claude annoys me. So what were we doing? We were celebrating that we only have 2 examples to go, and they work when independent Watchdog doesn't. Like, if I will not find a solution, I will just make a rule that I will actually just literally remove the windowed option from my implementation. Like, windowed option will just not be allowed, and I will be like happy, and this will be it. this will be my solution. Okay. So this example already works and we already confirmed this. But this should be an example of the correct right. So let's write the explanation. Example of the setup of the Windows that is properly reset by firmware. It's not cause MCU reset. Correct. 500. So any reset from 250 from the last reset is also very important. Is a correct Watchdog reset from the last Watchdog reset. Okay. Bring RDPA every, let's say 300. We already confirmed that it works at 260. It's kind of a terrible number, but whatever. 300 milliseconds. And it says Windows Watchdog, so Windows Watchdog doesn't set MCU. Correct. So observe that RD is blinking with 600 period. That means the system is not reset by the Windows Watchdog, or else it would have been always on. Correct. And this is correct. So this example is ready, finished, correct, done. Back to original. Okay, I will fix example 3 off stream because this annoys me to death. Let me just go to example 3 and example 4 actually, and make a to do IVDG with window currently doesn't work correctly. Okay, let's do the same here. Very sane programmer. Let's go back to our example and let's see if this is correct. Do we need to note anything else? I don't think so. So let's make our last example. And our last example will be new folder. Example 808. And this will be VVDG. And this should be example of early reset. So early. Oh, too many big letters. Early MCU reset. Okay. So now let's make a build for this. Course, manage. New example 08 debug. Okay. Okay. And what we will do with this is we will switch to it, remove this, add this. Okay, go here, remove this, add that. Apply and close. Switch here, of course, as well, and build. Okay, so it builds correctly. Yes. But what is the issue? Unknown destination type. Oh, I forgot to copy the main. Sure, of course. That's quite a mistake to make. Let's build it again. Now it's fine, which is very nice to see. And let's open the example. Let's make it correctly incorrect. And let's flash it, and it should reset our microcontroller. And why our microcontroller is reset actually? Hold on a second. Let's switch back to example 7. Hold on a second. Why is the microcontroller currently reset? hold, run. So it blinks. Can anyone in chat, if anyone was watching the stream, say if it stopped blinking randomly at some point? Or am I tripping? Let's wait for a minute. Not for a minute, is quite a bit long, but... No, it seems to be functioning fine, I guess. Okay, so let's switch to example 8 then. Back to example 8. So let's see our main. And let's flash our example 8. Which we cannot do because we haven't created this yet. Debug 8. 8 here. And here. Apply and debug now. Of course, you will require me to reset MCU. No worries. I can do that. I can do that. And now that it is reset, let's put it back. Let's flash it. And now our LED should be always on. Right? It is perfect. Perfect. So documentation, and at this point we are done with these examples, which is very nice. Example of the setup of this window that is that resets MCU due to watch or VVDG reset being called too early. Okay, so these are correct. Okay. Rise to blink PA LED every 200 milliseconds. Which and reset the watchdog. Sorry, need to drink the water. Hydration optimized. And reset VDG, which causes the MCU reset due to window being a VVDG window being set to 250 milliseconds, like this. Okay, this is correct. Observe that LED is blinking with no, LED is, let's copy from another example because I would like to have a similar style. So now reset should be here. Okay. And put it here. Observe that LED is always on and maybe stutters a little due to resets and reset up. And MCU reset up, I guess. Whatever. Good enough. I think we're done. We are done with these examples. Let me actually push them to the GitHub off stream to not show you my Git. Unless you ask nicely, of course. And we will start working on the debug examples. So those are in here. Oh my god. Oh, what is that? Holy cow. What is that? Oh no, it is correct. Sure. 270 files. Holy cow. Example. Okay. What? Hello? What is this? Why are debug folders in the... Oh, what? No! I think I... Oh, no. I think I messed up the names for the debug I supposed to use. Ah, a mental damage. Yes, it should be debug example, not example debug. Okay, let's actually delete all of those. Of course, I will have 277 files. Let's remove the debugger. Holy cow. I lied to everyone in the chat. I'm a liar. Okay. Also, where are debug 1 and 2? Interesting. Let's delete it. What? Problem. Why can't you? Oh, let's reset the cube IDE. Okay, can I delete it now? Close this. No, I need this. Can I delete it now? I can. Okay, whatever. Whatever happened, happened. Whenever the case, whatever the case. Okay. So let's see. Now we need to go through all the build configurations and change the names to debug example 08. And we will copy this part and apply. And we will just paste like this. Apply, and let's make sure that everything else is correct. It will be also a reason for us to double check everything. This is correct. This is correct. 3. Correct, correct. 4. Correct, correct. 5. Correct, correct. Here. Apply. 6. Correct, correct. 6. Apply. Here. And 7. Correct, correct. Apply. So now let's build one of them. Example there says debug. What? No, I changed the wrong thing, I guess. Oh my god. No, this is correct location. I need to rename those, not that. Okay. We go again. We go again. Da, 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 da. And we need to make sure that all of them build properly. Because I changed quite a few things out of my own style. Fine close, and let's build it again. It builds as debug examples, and now it is not in the Git. Very nice. And the launch files are changed. And now let's compare to here. So what names do we have here? Cortical examples, debug example. Okay, so this was also needed a change, but this would have changed automatically if I used correct names. Very nice. And why this example isn't working? Because I changed this. Sure. This one needs to be changed, but not by me because I wasn't the author of these particular examples. Close project. Where the hell is this? And now let's go through all the builds, make sure they build. Boom. That builds. Can I build all actually? Is there a way to build all? Oh, I can do it like this also. This is a bit faster. Sure. Okay, and one more. So everything builds, and I have no garbage in my Git. And let me remove all of those, and let me make a Git commit uno momento. So these are files I'll need to add to the commit, and these are the files, and what else? This as well. Now include selected files, anything else, performance testing is named. Now I still have garbage, do I? I still have garbage. Oh my god. Let's actually open the git ignore and no, what? Why do I have garbage? Debug example. Oh, because I just didn't remove this. Let's actually build one more again. 07. Yes, I don't have the garbage. I just didn't remove the correct file. That's okay. That's all right. So, one second. Okay. I also need to include these files. 105 files to commit. Sure. And commit name will be G4 beef. This will be Watchdog. This will be edit Watchdog examples. Boom, bam. Let's get to work on our debug examples. Hold on a second. Why do I have an error here? What? Oh, because it's Cordic. Okay, sure. Because it is not what we are working on. And this is not what we're working on any longer as well. So let's create new project for our debug examples. So G474R pt. Next, let me hide it for a moment. Here, not here actually, here, here, G4, debug examples, and also copy the name, select folder, set the name, finish. So now, oh, so they are here. Okay, all right. Now we need to do the same process of organization of the repo, but a 2-minute break first. I need to refill my water. 2-minute break. Watch the motor spin. I'm back. So let's do the same process as we did before and set up the project to use all our dependencies first. And then we will start working on the examples themselves. And compared to Watchdog, I already have debug examples, but they are old and we need to update them. I actually believe that most of the old examples will actually work, but we will see. Let's first things first, set up the project. No point of imagining when we can just test. So let's keep the source for now, just to make sure the thing's built, and let's start adding our dependencies. Of course, we need an SDK right away. Okay. And we need to correct buses to be relative, not absolute. So dot 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 dot. Correct. Apply. And also let's include. Hello everyone, hope you're having a lovely day. I'm having a nice day. I'm working on the examples currently for my debug protocol to be able to read data from the microcontroller when it runs control systems without stopping everything or without the debugger being attached. And how are you doing? Welcome to the stream. Welcome, welcome. So, okay. We add it here. Let's include this, of course. Remove this at here. And also make it a source location. Removing some ports for a 10-inch server rack. Oh, I see. Professionally, or do you have such a rack at home? Let's also rename configurations, but this time let's use correct naming. The correct naming here will be debug example 01. Let's remove this. Okay, apply. Go to settings. Set our optimization level to fast apply. Rebuild, of course. Apply and close. Make sure that we used correct name. We did. So we've added our first dependency. We have at least more, I believe. So let's keep going. Advanced browse. SDK is done. General utils. Here at home, I'm building a very low power server cluster for my hobby needs. I see. And what is it? What are your hobbies? If you need like a proper server setup, quite curious. Are you trying to do some AI at home, or are you like doing web apps or something? Let's keep going. Fix the link resource path. Let's just copy from here. Too many slashes. Applying close, and this is done. Let's add it to our buses, of course. Network utils here and the bus here. Let's also add a debug. For this, we need another dependency, of course, which will be this one. Finish. Do we need anything else actually? Let's see. SDK, utils, and this utils, and that's about it. No other dependencies that we need. Nothing super fancy. I just deploy and build Internet of Things services for sensors and such to study software and databases in the space, just out of curiosity. Oh, But if you're doing this out of curiosity, do you really need like a full rec? But it sounds kind of fun. Any specific ideas you're working on right now? So debug examples, and we need to add device G4 here. And we can just straight up copy all the files from here. And we also need to do our MCU course. So anything else? I don't think so. Let's make sure that all the things are connected and related to each other. Oh, see daisy. Whatever. Dot dot. Dot dot. Dot dot. Okay. Apply and close. Open again. So buses and symbols. We have quite a few things to add. This first. While I could practice clustering on a single machine, though virtualization, through virtualization. Just like in production, it comes with its shortcomings. I would like to learn to do things the right way. Oh, I see. So you are planning to move at some point from the hobby and curiosity to something real? Like, is this the final goal or just a very deep curiosity? So what else? What else? What else? Also 2 folders here. Wrong pass, correct pass. So what else? Startup is not needed. G4 is added. And we will need to add our example here, of course. Let's also add source locations, which is this and that. That's about it. And let's go to the main. I remove this, remove that, and this and that. And actually, let's just open one of the examples we just made. Let's copy the includes. Here. I already work in the field with the same skill set. I just like to learn the things on my own time, both to develop my skills, but also I just like it a lot. Actually, this is a great way to approach things. I respect this a lot. I actually think this is one of the best way to go about your professional skills for the fields where this is applicable. Because it's not applicable all the time, but it's a very nice way to do it. Very, very nice. And this is a very nice way to grow as a professional. Especially in the modern day when a lot of responsibilities are separated between people and you just don't have a way to learn something unless you're given a task to do so, but you may want to learn it. So this is the main. Do we need anything else? We don't need watchdogs here. Oh, we will need quite a lot of things actually. Include debug utils. Oh, those are not called debug utils anymore. Those are called helpful debug utils. Sure. So what else? This is all important. Let's set up our clock. If setup clock. So now I think we should be able to. Let's actually also copy an LED code. Let's make sure that our code builds, that our code runs before we start working on examples. So copy this a bit too many times. Remove that. What drove you to build motor control from scratch? Actually, a very similar situation to yours. First of all, I have a major in control systems, but my major was not that well taught. And I had always had quite a few gaps in my skill sets that I didn't like. But I also was working with motors before for clients. And like I always felt like I kinda can do the work, but I'm not there yet to understand what exactly is happening. And even though I was working with motors, the controllers were designed for me, and like the most important software was designed for me, and I was just extending it. And at some point I said to myself, I would like to do it from scratch. Like, first of all, I like to do things from scratch, but more than that, I also want to have enough understanding of this to not be ashamed of my skill set, I'd say. And I also really like motor control. It's just a very interesting task to approach, both from electronic standpoint, from firmware standpoint, from architecture standpoint. And furthermore, when you do a great job about it, you just get a motor controller. And with a motor controller, you can do a lot of projects. You can do robots, you can do CNC machines, you can do some funny stuff, like being able to control a motor in a precise way, especially PMSM motor, which are very precise, very high power, opens so many doors. So like when this project will be done, I have so many ideas of what I can try to do, what I can try to learn, so it just opens so many doors. So this is one of the reasons I'm working on it. Okay, so what were we doing? We were trying to make this LED light up. So let's see first if it builds. First, let's see if it builds this one and just build it. It doesn't. Okay, no such file or directory. Okay, I think I forgot something somewhere. Yes, I did not include ARM utils here. Happens to the best of us, of course. Fine, close. Let's try again. Let's fix this quickly. And we are
That underscore onion is now following.
Thank you for the follow, that onion. I appreciate it a lot. So now let's flash it. And to flash it, let's actually close this. And let's force the flash so that it creates the first one itself. This is correct, and this is selected. Apply. And okay, and we need to restart ST-Link, of course. Let's do it. And let's flash it. And let's see if it works. Oh. Should be just blinking. And it doesn't work. Okay, because I didn't call the function. Oh, I didn't call anything in the main. How do I expect it to work? Holy cow. Oh. Classic. True. Okay, that was embarrassing. I'm not gonna lie. Okay. One moment. We are getting there. Everyone, stay in your seats. Yes, it did exactly what I told it to. Very true, very true. I have no arguments for that. You are correct. So, GPO A, ODR, and this, and GPO, ODR, OD5, and let's run it now. Should be working fine. That was embarrassing. Okay, let's run it. So now we're blinking. Now we are blinking, and now we can, after we confirmed that we are able to run anything, we can go and look for our old debug examples, and let's see what we need to move here. Also, we need to add another global include. So let's do it right away. And this include is a new one. It's a debug protocol that we developed yesterday. Not developed, but changed yesterday. So let's add it. Let's add it to the proper linkage. Like here. Correct, line close, then open again. Go here. Add the files. Not here. here. And this goes here. Okay, all right, so let's include the file. Okay. Should be built correctly. And no, was, oh, correct, because this is broken. Sure, sure. All right, whatever. Now, let's open the debug examples that should be hidden somewhere here. Okay. Let's see. Debug. Okay, so there are not that many of them. I think there should be more, I guess. Basic functionality, what it does. So let's read what our old examples do. Oh, hello, it's already... it's quite advanced already. Hello. Sure, basic debug functionality usage. Sets up USART3 with the baud rate for transmission and reception. Examples, queuing of multiple debug messages at the same time and their sending without intervention. Interrupts handlers. Okay. Okay, let's continue. Interrupt handlers need for debug functionality. Sure, handle itself as hidden inside the device debug.c and device debug.c. Oh my god, I think it's all will be broken actually. Whatever, let's make it from scratch. Let's use this as a guide, but not as our base. Let's do it from scratch, can we? Of course we can. So how do we do this? Let's add a folder. It will be... I don't like this name. Let's say example. Actually, I do like this name. 01 basic functionality. Basic debug. Logging. Whatever, we will rename later. Let's just move our files here. Actually, let's move these files because they will be needed all the time to our startup, and this file to here was... Oh. It copied, it didn't move. Is correct, so we can just remove this. And let's make sure that we don't have any unnecessary definitions and includes here. And let's add and include there. Now this is correct. So let's add the example. Do we need anything else here? Let me think. This is not needed. This is needed, of course. Anything else? I don't think so. Okay. Let's fix it if it breaks. And until it's broken, we are good. We are Gucci. So here is our main. So let's use it here. How do we set it up? We also need a UART setup correctly. And for this, we need to go and search for this and for this. Okay. It doesn't want to search for this. And where is my device folder? Peripheral interfaces. Okay, so we need those files. Copy it to here. Peripheral interfaces. Copy it here. Okay, very nice. I actually just want to copy one main, which is this main, which is from the basic example. Copy, let's say, here because we don't have it as a source folder, and let's close this to not have any unnecessary errors. Very nice, and now we can open this as a reference. Now, actually, I don't think that this old setup is correct. I'd rather use my new setup, so let's actually copy it from a different place. Let's copy it from here, but we will need to change our peripheral. But the way is roughly automated, so let's see. Okay. It will be in here, and the files will be the same. So let's copy them. And yes, to all. So we remove them, but they are setting up UART3, and this example uses, oh, it also uses UART3. So actually this might as well just work. This might as well just work. I have no problems with it just working. I'm only for it just working. Okay, so let's also then copy from our main motor control project a way to handle the interrupts. So we need to open our main. It just works, yes. It just works. I hope it will. Like, we will know if it doesn't in 5 minutes. 5 minutes until we know if it just works or not. So what was I doing? I was looking here, and I need 2 interrupt handlers. Got a bit of code here. It's all needed. It's all it's all intentional. So we need this and that, and I think this is it. And we need it in our main now. Here. And we also need to call 2 functions. And the functions are these. I was thinking the other day, maybe in 20 years, we will have SOCs as directly drive motors with big boy voltages, like all signal work would be as code. But I believe we already have a big boy motors driven by ICs directly. I do believe that it is partially implemented. Unless you mean something a bit different from what I'm imagining. Okay, and I also need a structure. This one. This structure is also important. And this is correct. And this is supposed to be here, and it is. Okay, very nice. And this example doesn't have a stream, so we will remove it. I mean, like, without any driver boards or amplifiers in between. So it's just feeding the motor directly. Oh, that would be like cyberpunk. Cyberpunky. Like, at the same time, we would probably have like 1 SoC robots at this point. Just attach the pins and it works. So, do I need anything else? I actually don't think so. Let's close this, close that. So, do I need anything else? Do I? This is enabled, this is enabled, this exists. These variables do what they need to. Everything is logged with problems. Let's build it. Let's see. We have quite a few errors because I haven't included the files. This is all right. Include. This will be debug. Pass. Oh, I know why, because we also need to include this to the pass. Sure. I guess at this time physics are still in the way of this dream, but motors keep getting more efficient and board keep getting smaller. It's kind of true, but kind of not actually. I would imagine that we are already at the physical limit of ICs. So microprocessors are already like a few atoms wide transistors there, and there is no much benefit or much drive, I'd say, to like move microcontrollers to smaller architectures, because you lose, I believe, first of all, you increase the price of manufacturing, and second of all, I think there are issues with analog stuff when you do minimize the transistor sizes. So I believe, I may be incorrect, but I believe that microcontrollers are stuck at like 60 nanometers for like quite a while. And they are not stuck because there is no technology to improve it, but rather that there is no reason to improve it due to the analog stuff in the microcontrollers. So from this standpoint, I don't think the physics is improving. So we are kind of limited by physics, quite a lot actually. But I may be incorrect. So don't take it as absolute truth, of course. So let's add our new bus here. And now we will be able to include it correctly. Right, and let's see if it builds. I don't think it will yet, because we don't have this. And we don't have this because we actually don't care about this. So we can put 0 here. And here as well, we can also put 0 because, oh no, actually let's not. Let's not. Actually, let's just define this. Actually, to do it correctly as a correct example, let's actually define this. And define this according to the way I use in the motor controller. So let's look it up. And it will be here. So this will be this section. Let's copy it, but only partially to the same file in this project. Like that. Boom. And we need to remove this and that. Nice. So let's close it again. And let's build it. It builds correctly. Very nice. Very, very nice. Now, to test it, we will need to attach our USB to UART converter to our nuclear boards. And first, give me a moment. I need to go and look for my second USB UART converter. One moment. Well, it didn't take long. Again. Now the connection is the biggest issue. Okay. So let's Google the pinouts. Nucleo pinout. Images. Let's see. Nope. Okay, good enough. And let's see how do we connect this. The example requires us to connect PB10 and PB11. Where are they? Here and here. Okay. Now, let's disable the power, of course, to not break anything yet. And we need to connect 3 cables. Ground is here, I imagine. Then we have our RX. And our RX goes to PB11 and it should be right above the ground. So here. And this should go to PB10 and it should be second one here. Looks good enough. And we also need to attach this to our USB, of course. One moment. Attached. The cable is almost long enough. It's almost long enough. So now, Now let's see if it actually just works or if I'm a dumbass. And what we will see, for this to see, we need to, of course, enable the beef setup. Okay, I think I didn't include everything I need. No, I did. So this function should be... okay, I need to go and enable this again and copy the setup code. I believe here and here. And I need to rename these functions, but I will do it later. Go here, set it. And this baud rate will be 5 kilohertz, kilobots rather. Okay. So now, do we have everything set up? I believe we do, but we also can do what? We can make our buffers, our debug buffers available right away, just for example's sake. So let's go and see what. Our main again, and let's copy this code as well. Let's copy this code as well, right after the setup. And we need to create those, of course. User2 uint 32t, user2 buff. It will be an array of... Actually, I don't remember the array of what. So let's just copy. Oh no, it should be debug buffer. Okay, I'm just stupid. I'm stupid. My bad, my bad. So this looks nice. This looks nice. This should just work. Hopefully. Hopefully it works. Let's build it. Now we don't have any problems with our life. Close this project. And let's actually flash it. And we need to go and open our Python scripts. So let's go and look for them. Let's go and look for our Python scripts. Where are they? They should be here and here. I'm doing this off screen. Yes, they are here. So here we are. Quite a lot of mess, of course. I'm terribly sorry. Okay. Now, let's see. Python scan COM ports, and we have our USB port on COM10. Sure. So have we flashed our firmware? We have. Let's run it. And it doesn't run. We have an infinite loop. We have an infinite loop because we haven't enabled the FPU. This is a very easy thing to fix, of course. It's incredibly simple to fix by copy pasting. By copy pasting from ourselves. Here, one liner. 4 liners, of course. And here, not here, but rather here. Yeah. And now it should work fine. So let's do it again. Was. Oh, okay, of course, because we don't have this function. But we do, because we haven't included this file, sure. Include, not this big include, but small include. Seals.if. And now it should be fine. Right. So let's flash it. Oh, I forgot to add one thing, but whatever. Let's run it and let's see first if our UART is connected properly. So we are still on COM port 10. So Python COM save error log COM 10. Device is not responding, sure. And most likely It is because I messed up RX and TX. It is most likely. So let's actually, the first thing I will try is to remove the power and to, also I'm not sure if this ground is good ground. So let's actually use power ground. And let's actually try again right away, because maybe it is a grounding issue. I don't want to change too many things at the same time. So let's run again. Let's actually, oh, this would be awful. So we are running, we are blinking, and we are checking. It's still not responding, but it's still on the COM10. Okay. So maybe I actually messed up RX and TX. So let me remove the power. Let me open again the pinout. And let's make sure that I am not stupid. So this is supposed to be where exactly? It's supposed to be one in the middle, in the breakpoint, and then 2 more. This is correct. And this should be second one to the connector, which is correct. So I think I need to swap them. Silly, maybe. So let's swap them here and 2 up. So like this, and let's try again. Like that and like this. And if we still have to flash again, we might as well fix, not fix, but add log error, whatever the error is, and multiple times so that we can see it in the log. And now let's flash it again. And let's see. Okay. We are here, we are running, we are blinking. Let's check the COM ports. They are, oh, they changed. So now we are at COM3, sure. And it still doesn't work. Uh-oh. Uh-oh. That's unfortunate. Okay. Now that I switched virus, the problem has to be in the code then. Okay. Actually, first of all, let's see if we have any errors in the error log itself. Error log will tell us if we have any easy to fix issues. Let's run it and let's open our error log. And let's see. We have what we logged manually and no easy to fix issues. Sure, no worries at all. Let's see what else we have in here. So we set up our clock, which is correct. We set up our UART, which is also correct. And we set up DMA for UART, also correct, sure. And this example uses UART 3, right? Let's first think and rather look at STM32G474 datasheet. Now let's make sure that we have UART3 on the pins we expect it to be. So let's move a bit lower here. So let's see. Sorry for the flashbang. Gotcha. What the hell? No, I don't like this. Next table. This one. This one is much better. So we were using PB10 and PB11, and this should be UART3 and UART3, sure. Okay, this makes sense. So these are correct. Now let's keep going, checking the code. GPIOs 10 and 11 are set on GPB, and the mode is 7, and we need mode 7. So this is correct. Okay, so what else is wrong? What else can be wrong? Okay, let's also see what actually. Desired baud rate. it uses correct definition. Correct definition, sure. So let's flash again and let's see if we, not flash again, we are already here anyways. So let's add this counter, both of them actually. And let's see if they are called by our Python scripts. So we are still at comp3. So let's probe it. It doesn't want to be probed. Sure. Okay, whatever. And we don't have any calls here, so the data didn't get through. Maybe I shouldn't have switched them, actually. But let's keep going through the code first before I start thinking of other things. Is this correct? So clock setup, GPIO setup. GPIO seems like it's blinking 1 time per second, which is correct. This means that time is set up correctly. We haven't made an error here. So this code cannot affect anything. This code is fine. Let's make sure. Yes, this is fine. Okay, so everything actually should work, but it doesn't. Very nice, very nice. Okay. Are interrupt names correct? They are. They are. Okay, let's actually switch the pins back. I changed my mind. Let's open our pinouts again. Whenever it was, whatever. Here. Let's actually combine them. So, PB11 should be one, two here. 1, 2. Okay. And PB10 should be here. Okay, we go again. Let's see. And we flash. We don't even need to flash. We don't. We can just try it. First, let's check COM ports. Now it's COM port 6. It doesn't respond. Okay, this is annoying. Let's see if I can see communication line triggering on the USB UART when I call the script. Let's see if maybe it is a hardware issue. Yeah, I can't see anything from here from this angle. One moment. Yes, it works. It kind of works, but it doesn't help. Okay. That's annoying. So now we checked both connections and we switched the ground. What else can be wrong? What else can be wrong? This is so simple, like there is nothing to break here, right? Can I actually send a message just to see if the UART works? And let's schedule a message every 500 milliseconds. So it will be... Oh. Or... Where is our implementation? It's here. Nope. Not those. This queue message, sure. Queue message. This protocol, and the message will be. And the message will be event 80 message. Something. Hello, Warsaw. Where have you been? All my life. You haven't been on stream for 4 days. I was counting. How are you doing? How are you doing? As you can see, we have more active chat now. More people are here. How are your things? How's your progress? So let's say this and that and this. Like that. Ah, you at work? But I thought you had more time. You were telling me like a week ago that you have 12 more days. I see now. I hope you are doing fine, like your work dangerous, so stay safe there. Stay safe, and thank you for opening and checking. I appreciate it a lot. So let's send the message. So you will be working for like next 4 weeks. Let's see, this and 3 here. And let's see if it will work. So let's flash it. Oh, company training, I see. Sure, that's also important. Oh no, I messed up. Should be message here and 3 here. So you're procrastinating from your exams and training. Ah, gotcha. Gotcha. Let's see, it builds, let's flash. So the data should be coming out. All right. Run, and I should, oh, sorry, see. Okay, device doesn't seem to be sending anything, actually. You forgot everything about FLC already? Like in 4 days? I get you. Actually, given how hard FLC is and that you haven't learned it from scratch, you were learning from my stream, I would imagine that you already forget it. Because like you haven't had anything to like solidify your knowledge, so this is absolutely fine. No worries at all. If you need another explainer, I can explain it again. Just ask. So, will memory get wiped? Overflow, memory overflow. Sure. Your memory got wiped by your company? Like I don't remember the name of the like show or film where like people were on the timer on like their hand, actual, and like in real life, if you don't reset your Watchdog in time, your memory gets wiped. Okay, so what was I trying to do? I was trying to see if our UART is setting up correctly, actually, because it doesn't seem like it does, or it doesn't seem like I use correct pins on the board. Something is wrong because I'm supposed to be sending data all the time, but I don't. And actually, let's see the parts of the UART implementation and the part of the protocol. So let's see UART protocol, add it to our debug variables. Let's see the content. So we don't have a com stream. We have 2 buffers registered, and txq is. Oh, so nothing is being sent. And why is nothing being sent? So data is not going out. Have a nice stream. See you next time. Thank you so much. Have a nice education, training, quizzes, exams, life. See you next time. You are always welcome here. So now, we have issues that data is not flying out. And why is it not flying out? Why is it not? Is a question for Emilian. Is DMA actually set up properly? Oh, it's DMA interrupt. But where is the DMA setup? It is set up here. But it should log an error, but it doesn't. And hold on a second. Maybe I know what the issue is. Maybe I'm just not a very smart person. No. Well, maybe yes, but not today. Not today. Okay, so how will we debug it? How shall we debug it? It is correct. Okay, this is the same explanation. Sure. Okay, do we have any calls for our interrupts? We don't have any, but should we? We should when the transfer is finished, but nothing works. Nothing works and everyone is happy. Why though? Why though? Who would have known? So, do I even need my USB UART converter to be connected for this to work? I don't think I need. I don't think, or rather I think that it should work without a USB UART converter connected. So. PQ messages, but they are constantly stuck, right? They are infinitely stuck. But that means that I should have errors in error log, right? Do I not have error when the queue is overflown? Oh, I have errors, sure. We are full of errors. 4, 1, 2, 1, 4. Yes, this is an error when our queue is overflown. Sure. Thank you for mentioning this. How do we solve it? Again. Clock. Let's go and see. Do I set up anything else here before this? Nope. Actually don't. It just works here. But it just doesn't work here. It just doesn't work. A new slogan. It just doesn't work. This is the second time today that thing just doesn't work. Even though it's supposed to. Am I stupid? Do I even look at the right side of the board? Let's check it again. I do. I do. Let's, but we know that the data is not going out. Let's actually use a direct send that is not a DMA send. Let's actually start debugging it correctly. So let me go and fetch my, oh no, I don't need to fetch, I can just grab it with my hand. So this is a logic analyzer, let's attach it. Let's use a logic analyzer to see if your art works correctly at any pin, and then we will know if we need to switch the pinouts. So the USB. Let's do the connections. So let's also power down everything before we do it. Let's remove it for now. And let's remove this. So let's move it to the side temporarily. And move it here. This is a very nice logic analyzer. I highly recommend if anyone wants one, buy this one. It's very, very nice. So we need a pin 1. It is TS Logic Pro, I guess. And for this to work, we need 2 grounds. 2 grounds, 2 grounds, 2 grounds. And let's see the pinout again. And let me maybe increase my screen slightly. One moment. Here. And like this. For everyone curious what I put where. So, which one is the ground? The ground is black. Okay, sure. So black is the ground and black goes to here. Okay, and then signal goes to the opposite one here. And we need to attach another one as well. Do we have another ground close? We don't. But we will rely on the ground connection from the first one then. So when we attach here. Okay, so let's attach our logic analyzer to the USB. Which we successfully do. Let's open our software. Logging software DSU. Here we are. Thank you. 4 is fine, but we don't need 4. Let's use 2 only. And let's make it longer. Let's change the names. Whatever, they can stay like this for now. Now, let's... No, for now we know for sure that bytes do not fly there. So we need to change the code first to see bytes fly. Or we need to give them a Red Bull. Ha 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 ha. That was a terrible joke, I'm so sorry. Close project. And go here. And let's remove this. And let's see if we have a function to send UART data directly. Go here. What do we have here? We don't have a direct message sent. That's annoying. Can we implement it quickly? I guess we can. I guess it shouldn't be much of a deal. But given that we don't have an easy solution for now, that's annoying. I should always have a function for debugging purpose here. So let me add to do. To do add a function that sends a message directly without using DMA. It will not be used in projects, but may be useful for debugging purposes. Nice. So now, let's see. Let's keep this for now. Let's keep this for now and let's flash it. We are attached. Very nice. Let's flash the code. Oh, hold on a second. Okay, this will be annoying, but sure. And let's start it. And we probably need to set up trigger. Start. And it waits for trigger, and trigger never comes because we have no data on this line. So sure, let's do it on this line. And there is no trigger on this line either. So data is not flowing, at least at those pins. And the data is not flowing through those pins, through neither of them. Through neither of them, because why? Why? Maybe... Do I even have a proper ground connection? I'm not sure. Let's try again. And let's test our readings. Start. No data. Start. No data. Okay. Okay. So, what is going on? Actually, what bloody is going on? Oh. This is a mystery. An absolute mystery. This is a mystery. Let's see if our registers are set up actually. Maybe they are not. Maybe they are not. I'll try it for a moment and stop it. And let's see what register do we need to check. UART3, of course, first. Where is it? Here. Let's compare it to 2. So it seems like it's set up and it's enabled. Oof. Okay. DMA interrupt. Sure. So this is set up. Let's go and check on DMAs. I know the issue. I'm such a stupid person. Fuck me. Half an hour for me being just stupid. I know exactly what the issue is. I'm not crying, you're crying. Okay, let's go. Let's go. And fix it. And this should be in here. Oh my god. I actually had the same exact issue before. And it will just work now, right? Or not, whatever. Oh my god. No, it does work. It's just for whatever reason is not red. So we have interrupts, so we're sending the data. We are sending the data, but for whatever reason we are not seeing the data. So let's actually remove the trigger. Maybe trigger is Maybe trigger was a mistake. Was. Hello? Thinking about it. Okay, I'm sure it works. I don't think we need to see it on the logic analyzer yet. So let's remove the logic analyzer. Let's remove the power. Let's reconnect our USB UART. It will work, I'm sure. I'm sure it will work. And everyone will make fun of me for the rest of my life. So let's connect again here. And here. So, okay, hold on a second. Let me open the instruction. Oh. TXPB10. Okay, and PB10 is what? Uh-oh. So PB10 is there, and PB10 is TX. So TX is you. So you go here. And that means that you go here. I want to this. And you go to the USB. And you go to the USB. And let's run it again. Actually, it should just be working. Let's go to our scripts. Let's scan our COM ports. We are on COM6. And it doesn't work. But first of all, we need to remove this code. And we probably need to swap pins. Hopefully. And let's run it again. And let's flash it this time. And run. And no, don't save. Close. We are running and we should be able to see something. What? Oh my god. Oh my god. Did I miss the connection actually? Did I connect it incorrectly? 1, 2. And black is ground. 1, 2. But I don't see the data even flying here. What is going on? Hello? Oh. We're getting there, we're getting there. At some point, we will get there. How soon is this point? I don't know. I don't know yet. So are you sending the data? Let's flash again. Let's flash again. Let's run. So, and let's open our scripts. It's on COM10 now. The data is transferring, but it's transferring in 2 ways. What? So something is happening. Let's actually... Oh. let's actually attach our analyzer back. Why can't you just work? So let's attach the analyzer. 1 and 2, and 1 should go where exactly? This. Okay. Who of you is 1? You are. So let's attach it from the back side. Like this. And also let's attach you. Here. I believe this is correct. Does it look aligned? It does to me. And now, the moment of truth. Connect. 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 Everything is connected. PSU. Open it up. Post triggers start. Okay. Okay. I hope it will start when trigger starts at any channel. This was my intention. So let's see. Scan COM ports. It's on COM6 again. Was. Oh my god. Actually, let's go to 100 megahertz and just like gets me. Stream mode. Disable all, only these two. Give me like 10 seconds run. Oh, clear triggers. Stop. Run. Okay, something happened here. What happened here? Okay, so we had 2 bits of communication. 2 bytes rather. Actually, we had more than 2. This sounds like a 2-byter. How many bytes are here? 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 2, 3, 4, 5, 6, 7, 8. 3, 1, 2, 3, 4, 5, 6, 7, 8. So this is a proper 3-byter, and the answer is 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5. Okay, so these are correct. So let's add our analyzer. How do I add an analyzer here? How do I decode, I guess? Plus select decoder. I see you are. Baud rate is 50K. And all of it should be okay. Baud rate, data bits, parity, charity. Okay. Sure. But what do you want me to do? Oh, I see. You want me to select one of those. Sure. AA5501. This is a correct way to request the error log. And what was the reply? And the reply was 50K. And the reply was 7966. What the hell? This seems like it's broken. 1, 2, 3, 4, 5, 6, 7, 8. So this should be a byte. Why is this like that? And the frequency is... The frequency is 370? Oh, maybe it is 370, I have no idea.
Devcode in you is now following.
Devcode News, thank you for the follow. I appreciate it a lot. The frequency seems to be like 250 kilohertz here, but 370 here. What? 370? So the frequency is incorrect here. Okay, so we have a frequency setup problem then. Oh. So frequency setup problem then. We are getting closer to the solution, this means. Let's go to the UART debug code then. I'm not sure that this is supposed to be here, but I believe that this is supposed to be correct. Also, now that it works, we can get back this line and see the frequencies there. So let's try it again. So let's try it again. And run it, and let's analyze it. So something is happening. We are sending something. And we are sending something that is broken. And it's broken because it expects different frequency. It does expect different frequency. So why do we have an 30% error? Or it's more than 30. Okay, sure. So frequency setup is incorrect. Now, actually, this is quite an interesting point. So let's connect another pin. So let's connect pin 3. And let's see if... I know the issue. Fuck me. I know exactly why it's 30%. Oh, I'm such a stupid person again. Oh my god, why do I copy-paste from the wrong place? I had 2 copy-pasting mistakes, and I know exactly what is wrong. Oh my god. Oh my god, not again. Not again. Where is it? It's here. Because nuclear boards come with 24 megahertz crystals by default. Now this will work. Unless I need to switch pins. Like, this is the last issue. I promise it will work now. Like, now or the next try. No other options. And I actually need to remove this. No other options. Now or the next try. So let's run it. And let's, we don't need this. Actually, we can run scripts right away. And we should be able to see COM6. It worked! So it saved our error log as this file, which is this file, which is 4 values and no errors. Hallelujah! And now we can also see, or rather save debug buffers. Buffers.py. Oops. Save dbg buffers. It worked. What is the file? This file. Yes, the values are correct, and now it's working, and I'm such a stupid person. I annoy myself so much. Nice. Now, 1 hour after we started, we can finally start making examples. Okay. Oof, that was tough. Okay. Holy cow, such... Like, I wouldn't call them stupid, but such annoying mistakes that first of all I had, like actually let me add a very important note that maybe exists, but I completely missed it to the file, because the problem with STM32G4, like one of the problems we faced, we had two problems. One problem is that nuclear boards use by default 24 megahertz crystals, and my board use by default 16 megahertz crystal. And because of that, because they are like 50% apart or 30% apart, depending on what direction you are looking at, we had this 30% error. And the second issue is that for STM32G4, there are 3 variations, and one variation has DMA channels 1 to 6 on DMA1 and like 7 to 12 on DMA2, and another variation has 1 to 8 on DMA1 and 1 to 8 on DMA2. And because of this 1 to 6 and 1 to 8 mismatch, the DMA multiplexer channels are mismatched. And this is annoying because my board is G431 and the nuclear is G7474. And because of that, DMAs are mismatched, and this is why we had an issue. And this is a very important thing to note, actually. So let's note it for myself for the future, to not be in this situation again anytime soon, hopefully. So we should go to the peripheral definitions, which should be in this here and here and here and here. Let's say simplified definition for DMA channels only used to improve readability. If other channels are needed, sure. Note. Note. Very important. Very, very, very. If switched from G4.1 to G4.4 or even G4.3, alignment between DMA channels and DMA MUX will be broken. So make sure to update to this and that to this. Now we are talking. now we are safe. Like the problem now is I need to remember to look at this note next time. Alignment. Ali gonna align. One moment. Align. Now, nice noise. Okay. I need a water break. After this stress, I need a 2-minute break. I'm so sorry. Let me go and drink some water. Instead of hardcoding it, can't you add a check to switch automatically? Oh, actually, this is such a nice idea. Actually, let's go back. This is such a nice idea, actually. Do we have a define for this? Do we have a define? We have this define. Is it good enough? Let's see. Actually, it's actually an amazing idea. Let's try to see how hard will it be to implement it. So STM32, G4, just G4. We need to see our variants. Let's see. Sorry for the flashbang. So we have 3 of them, and which means no. Let's open all of them and let's see the names. So they are all. There are 2 options: 431 or 491. Okay. And here are the options: are 473 only. Sure, very nice. And here are options 474 and 484. Wait a minute. 483 also exists. Okay. So we can do this. We can do this definitely. We will need to use this define as our base. So let's edit. Okay, cannot edit it. Just remember how it looks. Sure. Actually, a very, very nice idea. So let's do it. Okay. If def stm32g431xx. Can I use if defs? Actually, I don't know. Can I check multiple definitions in if def? Oh, okay, sure. That makes sense. If defined. Oh, nice, very nice. This should work. Nice. Here will be else. And here will be and if. Let's see. Or, and let's see our options. Where is my website? Let's put it to the side. Let's actually move it here to have more space, and here and here. Like, oh my god, one moment. Like this, very nice. So we have 4 variants. So let's see. Or this. Actually, let's do the most common ones first and then less common ones. Or this. Or that, which is A. We do this. Else. Now we need to go and actually, to make it proper, to make it very, very proper, we probably have to also use if here. Like this. Yes, else was incorrect. And we will also have an else. But we need to see datasheets, I would imagine. So let's see. I will figure it out very shortly. STM32G4 31 datasheet. So let's see it. Thank you for the idea, Mr. Das. It was a very nice one. So here, what are we looking for? We are looking for DMA descriptions. DMA. Let's see. So we have 6 here, 6 here. Sure. Let's now go to STM32G473 datasheet. DMA as well. Oh. Back. Here. 8 and 8. And let's go and check 474. DMA. 8 and 8. So we can actually use else because both version with 3 in the end and 4 in the end both have more 8 channels. So we checked this, and if this is not the case, we can do a bit less space here, and we actually this can stay. This is independent, but this is dependent, and as the dependence is oops, like that. And now we also should do this for the styling points, of course. And now let's copy this code to our UART code and let's test if it works. So let's copy it here. Right here. And yes, it uses different definitions. And it was like that, and now it's like this. So yes, we can remove this and it will work. And this suggestion was amazing. Amazing. This is very nice. I like it a lot, actually. I like it a lot. So let's also clean this up. No, for clock speed, it's definitely not needed. Clock speed is absolutely correct for all. It is the same for all GeForce. Only DMA struggles. As far as I know, only DMA has this issue where different microcontrollers within the same family have different peripheral like fulfillment. I am not sure, for the lack of the better word. And now that we implemented this, I can now go and fetch some water. One moment. Thank you again for the suggestion. So here is a nice view. I'm back. Okay, Mr. Das, I think I misunderstood your suggestion. You asked about clock, and I've rapid fire answered, and my answer was correct, but I think your suggestion was to make some kind of check if we are using like nuclear board. And this check doesn't exist in my system, but I have another idea how to do it. And we can actually implement this so that this doesn't happen again. And I was eating a kiwi fruit and I got an idea. And my idea now is that let's actually do it as well. I'm sorry for misunderstanding your initial like intention, because I thought like that it should be MCU defined and this is not possible, but it shouldn't be an MCU defined. It should be like defined by me. So let's do it. So let's go to our definitions file. And here, my idea now is to actually do if not defined, and let's say how to name it correctly, and if, and here we have a warning. Actually, let's have an error. And this will be, so how will we name it? We'll name it RSE clock frequency and short, like this. I hope it's correct spelling. And now it's incorrect spelling. Like this. So here we will have after ensuring that is set up correctly, for example 24 megahertz for nuclear, define this in your build. And now to make this work, how do we solve it? For example, we create a new project, we edit this, we have this annoying error, and we just go here and here, and we take this with us, of course, and we add this, rebuild index, and now it's gone. So it will force us to use it one time, because by default, when you create a new project, it's not defined. So this will ensure that at least once I will check if it's needed. This is kinda, I'm not sure. Some people may find this solution beautiful and some people may find it ugly, but I find it acceptable. Okay. Very nice. Very, very nice. Now, on the rush of this new idea, I would actually want to look for all the DMA calls in this project and actually update all of them, because this project, like this PCB. Oh, I'm not showing my screen. Holy cow. I'm stupid. Yeah, so this is what I added. Oh my god, I'm not showing my screen. I added this guard, and okay, let me explain again. I'm such a stupid. Oh my god. I'm so sorry. So this is not here by default. These are default definitions. So when we copy this file to a new project, this will be an error. So if we build, this will force an error on us. And the error will say that change this, like make sure that this is set up. And when you do, make sure that this is set up, you go here and you add this definition here, and it's gone. So it forces you to check this value one time, every time you create a new project. So this is a solution here, and let's now go and look for all our DMA calls and make sure we change them all to the new system that we just introduced. so that we don't have any errors when, for example, I would like to move this board from G431 to like G473, because currently we use 431, as you can see here. Okay. So, let's first find our initial implementation rather. And how will we look for it? We will look for it like this. Like this rather. So, I think even though it will not change for every place, I should put it in every place just as a style guide. So let's do it. So let's do exactly this, and let's search our project, and this is this. Okay, this is already changed. Oh, there are quite a few places here, but this is not my place. These are predefined by ST. Sorry for giving you more. What do you mean? Like, this is a very nice work. Like, this is such a nice change that will help me a lot in the future. Like, I appreciate the suggestion a lot, because this is how you make your code like less error prone. Like, now I will spend like 20 minutes implementing this, but if it was implemented before, we wouldn't have spent like an hour finding the problem. Like, even a single issue like this would, even like the time we will invest now would have saved already more if we, by us not like doing the debugging we just did. So it would already be paying off. So absolutely no issues here. More suggestions like this, please. More, give me more. Here, so let's copy paste this, and let's see. So let's go place by place. This is implemented, so we also have this file. This file has quite a few actually, because we have 2 encoders possibly, and let's do it. So channels are whatever they are, and let's split them by the encoder like this, and those can go together as well. And we need to see. This will actually stay the same because they are below 6 on the first DMA, but we anyways put it here for the style guides, for the style guiding. So we do it like this, and this can go up, and this can go to hell. Do I need to do anything here? No, I don't. And I also need to remove this and copy this again, like this. Very, very nice. So now it will work correctly. And let's go and update one more place, of course, which is here. Oh no, this place is actually, I actually can remove these files. They are not needed anymore. Let me actually do this. Where are they? They are here, and they can be deleted. So, and I think we've actually had only 2 places here. Okay, that's fine. This was like a 2 minutes update, and it could have saved us an hour. So, not a big deal at all. So let's do another search just in case. Okay, search. I've been searching for the answer. Oh, we human. All we dancers. And I'm on my knees. We also have comments, and comments are incorrect. But we can't do much about comments, right? Should it even be in the comments then? Like, the comments is kind of useful, but it's kind of broken with this system. Maybe I can do it like this. G431. G4 the 9-1 rather, G4 for 1 and G4 A1, and we can copy this. For all other G4s, and this will be 8 and 9. This can solve it. This is acceptable, I'd say. Quite acceptable. Acceptable. Blah, blah, blah. Blah, blah, blah. So we also need to change this comment then in this place. Oof. Oof, oof, oof. Let's move it like here. For the ease of copy pasting. Like that. And like this. Everything else. And they will be the same, which is intended and known. And this will be as well similarly. So like this. Oh, my camera is getting discharged. Uh-oh. And we also need to copy all of it once and change the description. Nice, very nice. Now comments are stable, comments are not breakable, and the code is not breakable either. Very, very beautiful update. I like it a lot. So now let's actually I'd say let's stop for today. It was quite a nice session. We will continue tomorrow, but tomorrow I will start later, roughly 19:30 CET, Central European Time. So if anyone wants to join, please follow and join tomorrow. Thank you everyone for watching. Thank you for suggestions and jokes and everything. I appreciate you, all of you, a lot. And I see you in the next one. Bye bye.